Made that last night for made this last night for my pole vault. There, it's called a pole vault putter upper. Um, I don't know. I'm hoping it'll work out. I've done one before, but I didn't use. I didn't do this. I have a pool extension thing that can like reach real far, and I was going to try to put it on there.
Yeah.
And then I've done one before where a lot of people, what they do is they just attach some stuff to the end of old broken poles. And so I've done another one where this
Can
is
you hear
like,
me?
yes, ma'am.
Yes, we
I
can.
can't hear anything.
It's gonna be your computer speakers probably or something on your output.
Can you hear me now?
We can hear you.
I just can't make your picture bigger. It won't let me. I'm on a different computer.
Um, but what I've done in the past is I've had this basically extend out farther. And what it would do is it would cover an existing pole vault pole. But I think this would
Yeah.
probably be a little bit better idea. So
So
I
what
went
if,
on.
okay. I was thinking, I was like, what if you got like some PVC pipe or something like that, and like you
I've
could like
tried
make.
making them myself with PVC, but the problem is they weren't um, sturdy enough, and it actually
Okay.
like messed up in the middle of a
Yeah.
kid putting up a pole, putting up the
Yeah.
crossbar.
They are flimsy. You're
Hit
right.
her, and it hit her in the pole actually came down and hit her in the head and cut her
Oh
face a little
damn.
bit. And that was
Yeah.
fun.
So what would they go on the end of? Like you said, a pool extension thing, or like a
Yeah,
broomstick or
yeah,
something?
they have the Acme threads.
Okay.
So I looked up how to do the Acme threads, like the trapezoid that the Acme threads have, and then I just coiled it.
Oh wow,
So
that's pretty neat.
I'm hoping, I don't know if it'll work perfectly, but I'm hoping that my entry is going to be good. I think
So
that looks fairly decent.
yeah, it's pretty neat. So I know I mean there's a thread tool on the on Inventor, which is really good. Um,
Okay, now, does that one actually make threads, or does it just give you? Because whenever I was looking up whether or not you could do threads on here, it said that these were not actually going to be threads that would 3D print. You'd have to get
yeah.
like um, another what do you call it? Like an app, like an add-on kind
Oh.
of an app to make it work. Is that just old information?
I mean probably so. It should anything you make in a 3D model and you export as an STL is gonna print. I don't see why it wouldn't. So like the thread option, so like I have the thread thing pulled up right here. I just made like a quick cylinder. It's like nothing crazy, but like I mean we could look at it right now and see. So let me share my screen real quick. So
Well, I know on Onshape at least, its threads were fake, so they were just for you to know that there was supposed to be threads there. If you 3D
yeah.
modeled them and you actually
Okay.
printed it.
Well,
Now,
let's
I never
see.
had an
So
issue like
yeah.
what you
So
call it. I didn't
I
have
just
an
made a
issue
regular
with.
cylinder, and then we have the thread option right here, and then you can choose your object, and then you could even put what type of threads you want. Um, I'm not sure what was the name of the threads you're talking about?
They were Acme. It was 3/4 Acme 5.
Okay, so I don't see Acme, but like I
I was
mean,
about to say I don't think they have it on there.
let's just do trapezoidal threads. That's okay. So I mean, it has a thread scenario on there, but I mean, pitch wise, I'm not sure what normal pitch is on certain things. We'll just do it with that. Let's see if that even.
But is it
pops
actually
up.
modeled, or is it just displaying it as a picture?
Well, let's see.
It doesn't look like it's moved.
Yeah, it doesn't look. It does look like an image. Let me see. I'm gonna export it. Export is a step file, and then I'll just do my download. So I don't. Why do they do it like this? I feel like it changed the way my folders look. All right, so there's the. I just made it. You might be right. It might be speed, but I feel like it was more than just an image, but because it doesn't look like the diameter is different. But let's see. I'm waiting for mine to pop up. But yeah, there's a coil as in the sketch thing, I think. I can't remember. I've never actually used coil before, but maybe it's 3D sketch or
3D,
something.
just one of the 3D model things. It's like the third one from the
Right
left.
here. Coil. So you basically have to draw. Let's see. What does it do? So it creates a helix coil, spring, or thread feature. You can specify parameters of the coil shape and size and ends and stuff. That's pretty much the same thing. So maybe you might be right. Maybe might not be anything. Let's see. Yep. Not actually threads. All right, you learned something new, I guess. So yeah, it's just the cylinder exporter, not the threads too. So yeah, so
Apparently, the
threads.
threads is too much data.
What's that?
Apparently, the threads, the helix concept itself is too much data.
Yeah, probably so. I mean, that's a lot, and as fast as it made it, that's pretty crazy. All right, the threads are just appearance-wise. That's kind of a bummer. Let's see. So coil, you have to make a sketch or something to do a coil. I've never used a coil before.
Yeah. So what you'll do is you'll so like you would go and you would do a what's that called? The one where you can see into the plane, like you can cut through and see into the what
You're
is
talking
it?
about
It's
slice graphic.
slice graphic. Yeah, that.
So start a new sketch. Slice graphic. This one
And then you'll
says
draw your picture.
okay.
And then so like here, let me just pull mine up so I can show you.
Yeah, that's fine.
Might be faster.
I'm reading the instructions on it.
All right. So I did my normal extrusion, just made a simple cylinder.
Yeah.
Then let's see, just one. No, it's not. So then I made my hole. Then to make my coil, I had to make my next picture. Let's do. So I made a picture that was on the. I just did on the front plane.
Yeah.
I'll do.
Slice graphics at the bottom. Yeah.
I always go through the view. Where is it on the bottom?
At the very bottom, in the mid,
Oh.
yours is actually towards the left. There's that little thing selected. There's a little blue window looking thing. Yeah,
Yeah,
that right
that.
there. Yeah.
So yeah, so then I got on that plane to where I'm at the edge of my hole, which would be my inside of my inner diameter for my
Okay.
for the insert, the male end.
So you just need
So-
like a enclosed shape basically to do it.
Correct. Yeah, and so what I did, I looked up the Acme type. So I looked up what type of threads that was on that particular brand of. It's actually a window extension cleaner pole, and I looked up what brand it was and all that, and I got the different specs on it. And so then I looked up how to make an Acme thread, and it's basically just a trapezoid that the pitch You do half the pitch for the width here and half the pitch for the height here, at an angle of 29 degrees. That was the specifics on it for that particular size. And then from there, all you have to do is after you've created your image, you hit the coil feature, and you just tell it how far down you want to coil.
So
And
it's
just
basically
put all the way
it's
down.
basically revolve, but
Correct.
in
Around a cylinder.
Yeah.
So you pick the
Okay,
axis, and it just goes around the axis. And so you can do it to cut if you want to make like what I was doing, which was female, or you could do it to add like if you were making the male side.
And you can do a closed start and a closed end too. And I'm looking at it right now. I've never used it. That's pretty cool. I like that. Change the pitch of it as well. And you set an end point, I guess. Is there a
Yeah, you can basically make it go however far you need it to go. I forget what
I see Revolution 1 pitch the 0.5. Okay, yeah, I got it right there. There should be like an up to option. That'd be nice, but okay. I mean, you just said it right. Be good. That's pretty cool. I've never used the coil method before. I like that. That's different. I guess now that we know that extrude the threads is just is imaginary.
For sure.
It's not real.
Yeah. Well, you can use them. So from what I read, it said you can use it, but if you're going to use it, you have to go in and you have to get an app that you can add on to that'll like read it for you and then make it show up.
That's annoying.
Yeah, exactly. Which is why I just went ahead and did the coil method.
Yeah, absolutely. No, that's definitely what I would do. Okay. Yeah. All right. That's fine. Cool. I like learning new things, so that's pretty good. Yeah, we don't. I mean, that's not even a necessary tool in Inventor, but that's one of those things where it's like students, if they're my disappointment so far with my students, I guess. Not that they're not good, but I haven't had like as much investigative students or curious kids in the last few years. I've had kids who are just like they're satisfied with just doing the class and or they're just doing the class to finish the class. You know, they're not actually super curious. I've had maybe 2 kids in the last 4 years that are like legitimately curious. Maybe 4, I'd say. I gave 4, but not like that curious. You know, not to actually be like, all right, how can I use this? I don't know, but that's cool. I like that. I like learning stuff like that. So that is really good. All right, so perfect. We need a sign-in word. So because in honor of Josh's awesome new thing, we'll say the sign-in word will be threads, or actually coil, because it's not threads, it's a coil. The sign-in word's coil. I don't know where everybody's at today. We got 3 of us. I know Nick's traveling still, but I don't know where everybody else is. All right. To respect y'all's time, we're going to move on. All right, and we're going to get started. So before we get started, what I want to do is I'm going to put a little bell ringer up here on the screen for you guys to attempt. So I'm going to put that on the screen. Screen 2. So this right here, this is going to be our 6.1 teacher notes. I blanked it the solution out on part 1, but there's 2 parts to this bell ringer. I have like a PowerPoint that I have like a PowerPoint that I have for my class. That's just like bell ringer PowerPoints. If I want what I want them to do, you know, it's just for the whole year. And this would be on that PowerPoint. I just don't have it open. But bell ringer 1, if you can't see the model menu, how do you make it visible? To do this, try and make the model menu go away and then come back. This is a tested question, kind of tested question, I guess, but not that serious. And then part 2 is try to make a simple coffee mug with a handle. All right. So go and try these 2 things out. And then while we're waiting on that, does anyone have any questions on section views or drawings at all? Is there anything I need to talk about or assist with on the last topic that we talked about yesterday? Is everybody doing okay with that?
The quiz had a lot more on it than what I was expecting for that quiz question, because you had to do an offset instead of a full or a half.
Okay. Let me see.
So it was a lot more involved. But I also noticed that it was originally from Unit 7 instead of Unit 4.
That's what it used to be called. Yeah.
Okay. So I'm guessing at that point we would have already gone through a couple more things.
Well, no, it just we renamed them. So
Okay.
like it was used to the first three lessons that we talked about. Those were 1, 2, and 3, and then so the inventor unit was actually unit 4. So it would start 1, 2, 3, and then 4, 5, 6, 7, 8, 9. I think it went to 11 something. But I was like, I just thought that was kind of confusing because we would get into unit 1, 2, 3, and then we would start inventor, and we would call that unit 1, but it was actually the fourth unit. So I was like, how about we just make the first three 0.1, 0.2, 0.3? And I missed a couple of units apparently that I didn't correct the label on.
Okay.
Yeah, I'm looking at it
Yeah.
right
So,
now.
I mean, if at some point we get a chance, we can go over that just to make sure
Yeah.
that went well. Because I mean, I think I did it right. Because I've had some experience doing it in
Yeah.
other courses, so I'm hoping I did it right. But I just want to double check.
I'm taking a look at the quiz, and it probably needs to be changed because
Question one's it's a little harder than what I was ready for.
so that was quiz unit 4 quiz, right? The section views, yeah.
Yeah, the
Okay.
first one where you had to do like there's 7 parts that you have to do. Like you have to, well, it's not really 7 parts, but there's 7 parts to question one, and like
Yeah,
you have
different.
to
Yeah.
do the section view, and then you have to do all the different dimensions, and you have to what type of section view are you doing, and all that.
Yeah. Okay, let's see. Create a drawing this part, including 3 multi-views and isometric. Include all appropriate annotations. The front view should be a section view. You should choose the most appropriate section view in order to adequately see all the necessary components. Change the view identifier to be V, which we looked at before. What type of section view did you just create? Isometric, change the style. Shaded, change the scale. All right. Type projection used in most ANSI-based drawings. You said there was an offset option
What
on
is
that?
this doing?
Well, you have to do an offset in order to do that particular section correctly. It's an offset section because you have to go through like the holes and everything don't line up.
Okay. Oh, you're talking about the. All right. Let me open that real quick. I know. I know. I think I know what you're talking about. It's got the. You have to. All right. Hang on.
Yeah, you can't just do a normal full section where you just slice it in half and get
Yeah.
everything you want. You have to go like you have to do the hokey pokey with it a little bit to get it to go through everything.
Yeah. Where is my? Where is that? All right, I'm just gonna look at it. Where's my folder?
So I might have done it a little convoluted because I ended up I made my original 4 views. I suppressed my front view because it said it wants the front view to be the section view and a section at the top.
Is this isn't the part, is it? Right here?
Yes, that's the part.
Okay. So yeah, this one, oh man, I need to line those up, I bet. Because yes. All right. So this is the homework. This is the quiz. Let me pull that up. Yep. I see what you mean. Because of the way it's done, that's not what I want to pull up. I want the quiz right here. So this is an inventor stylish question, which I like the format of it, but yeah, I agree. We didn't really extensively talk about the way this one's done, but it's not like impossible. But yeah, you have to align it correctly in order for it to work out. So yeah, with this
Can you
one, it
open my
says,
quiz and look at it or no?
go
Would
ahead.
that be easy? Can you open my quiz and look at what I did and just tell me yes, no kind of a deal? Or
I can't. I haven't even looked at it yet. Let's see. It was day 8, right? Yeah.
yes.
Yeah. First part. Got so many windows open. No, we don't need you to open. Looking at quiz. This is it right here. Yeah. I'm about to open it on the screen. No, you don't mind? There's the part, and then where's the drawing? see the part file. This the drawing. Yeah. I'm not. Oh, there it is. I see it. There we go. Yeah, no, you did it right. Now on this one, yeah, that looks pretty good. And then you got the circle. Yeah, because you definitely should do the front view as a section view for sure. And then the right side has a good bit of hidden lines too, which is frustrating. But yes, this honestly, man, this part has a lot.
Well, one positive about the right side with the hidden lines is those hidden lines are all covered in the top's hidden lines.
Yeah,
Or I guess it would be the actual. It's
correct.
covered in the section basically.
Yes, correct.
Yeah, it was a bit of a doozy because it kind of asked you to do everything.
Yeah, yeah, there was a lot. And like one thing that you can do if it's like over, it's too much for them to kind of finish because section views, especially this one, if I had more time, we would have talked about moving through that object, but we were short. So um, definitely, this is something to go over with the kids whenever like you're working through it, and like it's really not hard to do the section. It's just a little different. So, and in this one too, you could also like if you feel like it's too much time for the kids, you can tell them don't worry about the dimensions, or at least, or maybe dimension specific parts of it, like only dimension the top view or something, or the front view. And what's frustrating too with a section view drawing, I feel like it's kind of one of those things where I don't normally dimension the section part or like the part that has all the lines through it that cuts through it because it's like there's so much going on. There's too much going on. So I feel like
Well,
there should be like
putting stuff in a place where it seemed to make sense without over like crossing lines and all that was not fun.
absolutely. So
But like
yeah,
for that, you could
what I would
just
rec
line it up.
and I even do this depending on the group because I feel like just doing the section view itself can take some time and figuring out which one. So there is a depending on the scenario, there is a way. I mean, you have the option to be like, all right, you don't need to fully dimension this thing, just dimension, specific components of it. That's fine if you want to modify it that way, but it just depends. So we're gonna go ahead and put this one in the drawing. It is me quiz one, part one, top, and there we go. We have our three. So mainly what I'm looking for in this one is, I guess it's kind of I've been telling you guys to like put the drawing that has the most hidden lines, and that's kind of a equal battle between the front view and the right side. So that way you have to kind of think about, all right, which one's going to show me the most internal features that are going to be more valuable, and that's going to be the front view. The front view needs to be my section view because that's the only way we're actually going to see the inside of all of our internal components. That's going to be the inside of this sloped edge, the inside of the circle, and the inside of the slot. Now, the main problem is that they're not in a line. So to simplify this, if you wanted to, as the instructor, you could edit this to where they would be all down the center, which is not a very hard fix. Like you could just go and edit these sketches and make sure they're all in the center line. Like if you just went and edited this circle, you could change that position, just make it in the middle. That's an option. You can delete this dimension and just move it with a horizontal constraint like this. To make it a little easier for the kids if you didn't want to, because it's already enough to do a section view. You have that autonomy if you want to just kind of don't, because there's nothing really honestly, there's not even like a section view scenario that the kids actually have to do on the test. Like I don't think they tell them to actually do a section view. So you can do it like that to where everything's centered. And now when you look at it, it's all down the middle. So that way you can just cut it straight down the middle and you're done. There's not anything too complicated. So that is an option that you have. But I want to demonstrate how to do it without that option. It's not hard.
Yeah, that was what surprised me. That was what surprised me is that whenever we talked about it, we went over the slides and everything. It's like, look, these are the main two that we need to worry about or think about or talk about.
Yeah.
And then it
still is a half section view. It's not like an exploded or it's more of an aligned, I guess. But
that is it not an offset?
I mean, I guess like it's a combination of the two. I think because like an offset, and I get confused between the difference between the two. We're technically going through half the shape, but we're like alternating our path. So it's kind of a mixture between a full section and an offset, I guess. So, or more like an aligned section, but yeah, it's I would have demonstrated this in class, but I didn't do it yet. So, and I forgot to look at the quiz ahead of time to see what it looked like. So this is how we do it. We're still gonna do our section view. We're gonna use the top view as a section. So we need to get rid of the front view. So I'm gonna right click and delete the front view. You could suppress it, but I don't suppress it. I just delete it. And then the other two dependent views, you can click, change that to no, and it won't delete them. All right, the only thing is that it's going to be freely moving. So maybe suppressing it is probably a little better, but then there's going to be two things. I would just leave it right where it's at. Don't touch anything. They're in a good spot. So we're going to click section. I'm going to choose the top. I'm going to go to the middle, go out. Now we're going to go across. Here's the thing is that we need to cut into that circle, but we don't want to use this angle. We want to kind of go across. It doesn't really matter exactly how far you go. So I'll just go in between, somewhere in between these two lines here. Click again, go down, and then you can actually go to the circle and it'll give you that distance right there. And now it's in line. Click again, go over here. Probably about right there is fine. And then click again. We're going to go up. And then we're going to get in line with the center of this slot. Click again, and then go out of the shape. And then now we can right click it and continue. I can probably go back and change this drawing, and probably it would be best to change this to just a half section view. That way you don't have to do all that craziness. That's a lot. So, and then there's our drawing. So my main focus, oops, I don't want to change that too much. My main focus on this section, on this this topic, is can they do a section view and can they change some things? So I think I want to say that on my quizzes, I'm like, look, don't stress so much about dimensioning. This is not the priority in this topic. The last unit that we did was a priority. My priority is, can you make a section view, and really, can you do a half section or a full section? All right. So I'm probably going to go and change this to have. What I'll do is I'm going to add two parts in the Google Drive. One's going to be a simple full section, like let's say nothing too complicated, and then you can have like an advanced option. You have two options. This is like more advanced, and then the other option is just a full section, because that's all you really need to know. All right, so can you do a full section? Fantastic. So the next thing says include appropriate dimensions, but I wasn't stressing that so much in this topic because that's not a primary focus. The front view should be the section view. You should choose the most appropriate section type in order to adequately see all the necessary components. So we said the front view is the section view, so you didn't have to guess on that one. Submit the drawing in the PDF. Change the view identifier of the section view to B. So this is this little guy right here, which if you double click it, that's not going to change anything. So you actually have to edit this one down here. I think it's the section view itself. Yeah. View identifier is A. You just change it to B. That's a tested question of like, what's the view identifier? That one we need to know. What type of section did you just create? And this one is an aligned full section, which I should just do a full section view. Update the hatch pattern to match the material of the part. Now, one thing you know is how to find the material of the part. That's going to be in the part file. And it's going to be up here at the top in the middle. Now, you can't see mine because it's condensed. So press the double arrows, and it's steel carbon. All right. So that's just going to be steel. So if you go to the hatch style and double click it, if you didn't memorize what these are, that's okay. Go down to other, and we're looking for steel. All right, so steel is the second option. There's no steel carbon, so just steel is fine. And then press OK. And then press OK again. And we change the hatch style. Isometric, change the style from hidden to shaded. We do that so much, that's just a natural tendency that they should automatically do. Change the scale to isometrics from 1 to 1/2. Add a note indicating updated scale. So we need to double click the isometric, change the scale to a half scale, press OK. Then we need to add a note on that one. So we're going to go to annotate, text. We're going to click right here and say isometric. It needs to be all caps. Is 1/2 Okay. There you go, 1/2 scale. That message just popped up was asking me if I want to do like a if it wants to convert it to like a fraction. I think I should press some other button, but I just press OK. All right, and then there we go. We have our thing. So this is really what I'm looking for when I'm testing the kids. This is the main priority for me. Okay, the dimensions are extra because first off, for a section view, to try and dimension this is a lot. Okay, because you have this section line, especially with this aligned or offset or whatever it's called section view. I can't remember the name of it. But it's a full section, but it's a combination of a full section and I think an offset. So I felt like an offset was a little different. Let me look at the different types. But my main thing is I'm gonna add two. I'm gonna add just like a regular simplified section to where you just go straight across and you're done. Because that's really all you need to test on. There's really no other reason for that. And in the admitter exam, there's no general knowledge questions. So there's no like, what kind of section view is this? That's not even like a question. So so it just depends on like what you're looking for. So and how much time you have and what's your priorities on this stuff. My priority is, can they do a section view? Can they change the hatch style? Can they change the view identifier? Like those are the things that I care about in this topic. Like that's literally all they need to do in this topic. So there probably needs to be some adjusting on this quiz and give like two options. One's like a super detailed quiz, and one of them just like, all right, this is the necessities, right? Meat and potatoes.
I was also a little confused by, so if this is a unit 4 quiz,
Yeah.
but technically unit 5 is when we do dimensioning. So I was kind of surprised / curious why it's asking them to fully dimension something if we may have not even gone over dimensioning yet at all.
That's an extremely good point. Yeah, because that's why I think that's one of the main reasons why I swapped them, is because it talks about this, and we don't even talk about dimensioning yet. So that's why I've been kind of confused on the order of things, because the kids don't know how it. They don't even have any dimensioning rules, and this is supposed to be the first thing. So that's why I do dimensioning first, and then I do this afterwards. So that's a good point. That actually is like a fantastic point. So I'm gonna take it out right now because we don't even cover dimensioning yet.
I mean, unless we follow the way that you do it and go 5 then 4.
Yeah, but even still, then I'm not stressing it so much. Like I said, when I get to this topic, I feel like the section view information and processing a section view and doing it is enough, like enough of a brain ache or like a headache to do, that we don't really need to stress so much on the dimensioning aspects of it. So, but it just
Well, and
depends.
also, I mean, you may or may not do kind of like me. Historically speaking, whenever I'm doing something like this, I would, for my working drawings, I would have done the dimensioning on the normal multi-view with the isometric. I would have done all my dimensions there. And then if I'm doing any kind of a section view, I'm only doing it for those parts that are invisible. That's the
Yeah.
only thing that I'm worried about. And that would be the only thing that I would section. So that's why I was kind of curious as to why you would fully dimension, like you said, how are you going to fully dimension the top part whenever you got all these section lines going through it and all
Absolutely.
this craziness going on? It's a whole lot. But
So so
it's gonna,
this yeah, I agree with you 100%. And in this scenario, what you would really have in real life, you would have a dimensioned drawing on page 1 of like the top view and probably the right side, and then on page 2 would be the section view by itself, dimension. You know what I'm saying? Like you would have it to where it was kind of like separated on 2 pages, which you can add
correct.
another sheet. There's a you can where's it at? Place views. There's a new sheet button that you could do 2 sheets on this, and then you could and for the homeworks, I forgot about that. I completely forgot. For the homeworks, what I let the kids do. Sorry. For the homeworks, I let the kids just put everything all on one drawing file. So like they can add multiple sheets to this and it'd be on one drawing. So
Yeah. Well, and also this particular one, doing it on A paper is almost too much if you're
Yeah,
going to
it
do
is
all
a
the
lot.
dimensioning on it.
Yeah. You would almost want to like do it on size C or B paper and then like make it like a 2-to-1. But yeah, it's the main thing. Could they cut an isometric for me? And can they change the hat style? Could they add text? Can they change the shaded? Can they change it to 1/2? Like that's what I'm testing them on, and that's all I care about, honestly. So I'm gonna
Okay.
change. I'm gonna add two. I'm gonna add a part. I'm gonna actually do this right now before I forget. I wish I could redo. I can't do that. All right, fantastic. All right, I'm gonna do this. It didn't take me very long, so we're gonna change this horizontal. It takes literally 3 seconds to do this.
Also, we don't have the answer key for this particular one. So can you go through some of the other questions just real quick?
Yeah, we
Because
can look at it
we
for
hadn't gone
sure.
over them, and I was just curious.
Yeah, absolutely. Let me do. This this is yours, but it's okay. All right. Okay. All right. That's fine. All right. So let's look at the questions here. So, which of the inventor file extension type names to use that are readable across 3D modeling platforms? That's gonna be across multiple platforms. I guess a DWG file is what we've been doing. What standard sheet size? That's size A. Which standard agency is standard used for engineering drawings in the U.S.? ANSI.
Question two is kind of a almost a trick question because I know that that's what we're using is a type A, but A4 is another name for 8.5 times 11 paper.
Oh, is it really?
Yeah.
That's funny. I guess in this scenario, since we've been using the size A paper, that's what they should remember.
Right.
That's fine. So which the first view you create in a 2D drawing is it's gonna be the base view. And whenever you're looking at your drawings, where's my drawings? Do I have my drawing pulled up? There it is. It's always base. That's the starting view you're gonna go with. To make views appear smaller on the sheet without affecting the model size, that's gonna be your scale. Blank is a term used for a complete set of drawings. Include working drawings. Include drawings of each individual part with the dimensions as well as drawings. That's going to be our working drawings. Sheet format, borders, title blocks are all within the drawing resources. That's going to be right here. Drawing resources, title blocks, all this stuff right there. Objects that are symmetrical can be shown effectively using this type of section view. So if they're symmetrical, what we're talking about, if they have symmetric, that's probably gonna be like circles and stuff. So we would use a half section view on that one.
That wouldn't be full.
So because it's symmetrical, well, remember the circular objects that we were looking at in the past, like when we were doing that one. That one, I think that's what we're talking about, rounded objects.
Okay. Because
Yeah.
that's one like symmetric how, like
Yeah,
if it's
yeah. I mean that honestly, I would you could accept A or B. I mean, it's they're both
like
in similar value.
the one that we just did is symmetric now.
It is now. It is. Yeah, absolutely. Yeah. In the section view areas that are actually contact with the cutting plane are shown with section lines. So these are called these little section lines right there. And my drawing is now changed because that. Can I expand that out? I can. That's actually great. Actually worked. All right. When only a small section of an interior area needs to be revealed, the drafter can use so when only a small area can be used, I would say either a half section
Or broken out, right?
broken out could be, but the only one that we've used was gonna be a half section. That's the one that shows that small part of it. I guess broken out would also work too, but we don't really talk about broken out at all. It's like not even. I don't even. Is it
But
even
they are in all those
the
so
options? Yeah.
I was using the slideshows and broken out. It's talked about like several of those are talked about a lot more in some of those slideshows.
I think I missed the slide deck on those. see.
So you showed us one, and then there's another one that's in there that has more detail on some of the other views and stuff.
Yeah.
And so broken out, and that's how I figured out to do an offset, was because it was talked about more in the other slide deck.
I'm not
And
even seeing
then
the slide.
there was a couple more that were in there.
I'm looking through all my section view stuff, but I don't see another slide deck on. I knew there was another one, but I don't know. I don't see it. The section views and inventor drawings, inventor working drawings. That's just teacher notes, section view, teacher notes, full and half sections. I don't even see another slide deck. There it is. Sections continued. Okay. It was in the middle of all my other stuff. Yeah. Okay. It does talk about the rest of them. That should just be one big PowerPoint, but all right. Yeah. So the
Well, it
broken
looked like
out
it
is that.
was, and then they like revamped it.
Yeah. That's it. Oh yes, I completely missed this PowerPoint. Yeah, definitely fine. It's not in a. It's like kind of in a weird spot, but there is the section views. It's under backup material. I would not put that under backup material. I would put section views extended.
Agreed.
That's why I didn't find it. I just edited that one. That one's extended, not backup. Yeah, or continued. Gotta change that. Yeah, that's why I didn't see it. Because I was like, okay, this is backup material. I don't need to look at that. I have it because I have like my downloaded stuff. That's what I should be looking at. But I'm just trying to go through the classroom. All right, it's there. Yeah, absolutely. And that's just informative PowerPoint on there. And it just says has different PDFs of different types too. So it's in this folder right here is what Josh is talking about. So it's in good unit 4. So it's in section views, and then it's gonna be section view research, and then section views continued. And there's this right here. This PowerPoint is what he's looking at. I actually have it open. And it goes a little more in detail on all the different sections and stuff. So it talks about these bottom ones that we didn't talk about: aligned, offset, broken out, revolved, removed, those different ones. So, but yeah, that is it's not something that like if the kids don't know this PowerPoint, they're not going to fail the inventor exam on it. So I do show that later on, but I forgot about it. I didn't know where it was in the Google Classroom. Sorry about that. So in this type of section, the half of the object is removed. That might be why I was confused on the actual like because this part of the pre-test and the post-test is what I probably missed the most on. So I probably just missed that PowerPoint. So definitely reviewing this one is going to help a lot. So we have aligned sections, which is an aligned section is where we've talked about aligned drawings. That was the conventional versus aligned, making sure it stays aligned with the actual shape of the part. Here's another the conventional versus this is conventional versus the the special conventions what we're going with. Offset, that's what we just did. Offsets where like it's like a full section, but it's kind of following through that all of the internal components. Here's another offset where it kind of goes through. You can see it go through this object like that. And then there's the revolve section. So the revolve section is like it's cutting in the middle of it, but it's like flipping the material to show you what it looks like on the inside. So cross section of the part revolve 90 degrees to show the internals of that one. I think it's like a pencil or something. It's like showing the middle of it. Again, right here, they're cutting it like on this part right here, but they're showing what it looks like on that one. It's kind of a weird option. Remove section. So like they cut in the middle of it and then they just like brought it down to show you what it looks like in when it's removed from it. So remove is like taking it out of it. Here's another. I don't see the. Okay. Another removed one where here's our cross section or whatever our section, which is this is a full section from the top view front view. and they're just kind of pulling that information out and they're showing it from the side, which is kind of weird. But this is, I guess, how they do it in industry, just kind of nuts looking. That's super complicated, but it's just like a bunch of different internal pieces that we're seeing removed from the object. And then this is broken out. So if it's like we're trying to see a specific little side of it. This is a better example. They kind of cut. It's like that one of those jagged edges. So like if you look at my inventor thing right here, and I just only go into part of it, this little jagged kind of cut right there is kind of an example of broken out. But they're kind of just showing, I guess, what it looks like if something gets hit on it, and it's just showing like a little bit of the part, a little bit of that feature. On that one, here's another example of broken out, kind of cut like so. Another way too. So those are all the extras, not really super big deal. So we only have a small section. The interior needs to be revealed. The drafter can use, we'll say a broken out on that one. Absolutely. In this type of section, half of the object is removed. That's a full section. A section that allows the drafter to create a cutting plane, which is not a straight line across the part. That's going to be the offset. This type of section is limited by a break line. That one's the broken out. So if it didn't say a break line on this one, so when it's just a small section, I think it's a half section. So when only a small section of the interior needs to be revealed, we're going to do a half section. And then down here it says there's a break line, which is what that was, which is broken out. Aligned sections are most similar to a blank section, but have an angle cutting plane line that shows the constraint on a blank number of features. So it's definitely a full section, and it's going to be an odd number of features. Full section on odd. That was that this PowerPoint right here. It showed it right here. So this is 1, 2, 3 features to it, and that's where it kind of like they don't stick out the same exact distance. So you do that aligned this aligned cut, so it'll actually be visible like if it were even. You can change the scale of an isometric drawing without changing the scale of your multi-view drawings. That's true. We just did it, and that's it. Any other questions on that one, Josh?
The bonus, the first part of the bonus, I think it was.
This right here. The type of projection used in US and ANSI drawings is blank angle projection.
Third. Right?
Answer is first, second, third, fourth. Bonus. What is ANSI? So I think it's third projection. Yeah.
Okay.
Third. And ANSI stands for American National Standard Institute.
Yeah.
Absolutely. All right. Yeah, definitely a doozy on that one for sure.
Yeah, well, it was just unexpected. I was like, where'd this come from?
Yeah, you're right. That's on me. That's my bad.
Well, and it also looks like a couple of those questions might need to be refined as far as the wording. Like you said, like for broken out in half, they could both for the small section being cut out. But
so I think what I think is like, yeah, you're right. But then they go down and they see a break line, and they're like, oh wait, up here it doesn't say. Where's it at? It was small interior right here. It doesn't say a break line, right? So we know for sure we shouldn't have two of the same answers. So in that case, this one says
twice though.
Say it again.
Full was an answer at least twice.
Full right here.
And then farther down, it was full and something else.
Well, half is it seems like it doubles up. Yeah. Well, full's right here on 14. Full
yeah.
Yeah.
So I mean, I don't know. Maybe
full and half should be mostly on the test because full and half are should be the most popular. But yeah, absolutely. Yeah. So okay. That's good. I'm glad we cleared that up because that's going to help anybody else who's confused too. So thank you for asking that question. Absolutely. All right. Now to move on from my least favorite topic, which is drawings, are my least favorite. Absolutely. I'm not a fan of drawings like at all. So we'll close this out. I'm going to make a note to upload that part. I don't want to save that. Well, I'm going to try to save that. All right. And then, yeah. Okay. All right, we are done with drawings, which I don't like, but it's okay if you don't like them. You got to kind of deal with them anyway. So All right. I know the kids are always like, I don't like this part. It's like, I'm sorry, you still got to know it. So, all right. Let's look at this again. Let's try and look at this like I wanted to earlier. And if I wouldn't have goofed up, we would have had that. So, all right. Where is my stuff? This is all zoomed in. Why are you zoomed in? Over here. All right. So now we're going to get into, I find is probably all right, we're going to look at unit 6 now. All right, unit 6, let's go to engineering design. And in unit 6, we talk about machine holes, sweeps, lofts, and ribs. All right, so on the inventor application of these 4 options here, and that's why they're all 4 kind of together, is super simple. Okay, so I want you to, regardless of what we do in here and in this lesson, the actual application wise in inventor, as far as the questions they ask you, are surprisingly easier than I would expect. Okay, so I'll say that to kind of get things started. All right. So if you have trouble with this coffee mug, and because we're going to make a coffee mug using a certain tool, I'm not going to say which one. I think you can guess which one it is, but I won't say it. But you won't have to do something quite that complicated. It's generally as simple as the practice tests, which I'm going to go over at the end of this topic. At the very end of this class, I'm going to show you the practice test. We're going to look at it. We're not going to necessarily like do it, but I just want to show you like the type of questions that you'll see. But we'll wait for the end and all that. That way we're not like, trying to throw a lot of information at you at one time, and it can be kind of intimidating. So we're not going to do all that right now. Okay. So let's look at this right here. So bell ringer part 1, we need to start a new part. We're going to be let me save this one. We're in unit 6 now, but I'm going to go into my folders, go to this, and then it's summer trainings. And then I'm going to go to unit 5 and just get a bell ringer that we did. We didn't do a bell ringer, and then we did one in unit 4. Homework, or we didn't do about one. I know for sure in unit 3 we did one. There's a bell ringer. All right. I go to unit 6. I'm going to change this to 6.1. 6.1 bell ringer. There we go. All right. So the first part says if you can't see the model menu, how do you make it visible? All right. To try this, make your model menu go away and then come back. This is a tested question. It is a test. I mean, not really, but it's okay. It used to be a tested question. But it is a good thing to know in case kids start freaking out. Like, hey, my menu's gone, which I kind of showed this earlier on. We've already kind of experienced this. So this should probably be a bell ringer for unit 1, but it's okay. So if it goes away, like there's an X here. If it goes away, the automatic first idea is to click this plus sign right here and then model browser. So that's it. It's used to be a little more complicated. If it went away, you had to go to view user interface, which is right here, and then click on model browser, which is not that hard to do, but definitely just clicking the plus sign right here is super easy. So nothing too crazy. All right, the next thing is to try and create a coffee mug. And to create a coffee mug is a little bit tricky. Let me go ahead and I actually made this to where you couldn't see it, so that way I don't want to make that text go back to the right color, so don't forget that. All right. All right, it's super easy to do that one, so nothing too crazy on that one. So the next one was to make a coffee mug, and you should notice that it's kind of a challenge to make a coffee mug because you can't draw on rounded surface. So this is kind of how you probably should have made it. We'll start on the top view. I would say a coffee mug. I don't drink coffee, but coffee mug's about 4 inches in diameter, roughly. That might be a little big. Not sure. If I had I can go get a coffee mug at the counter, but not a big deal. And I would say it's probably at least 4.5 inches tall. That's about right. And then I would use the shell feature to open the top of it. All right, and let's make the shell thickness probably at least 0.25, so at least a 1/4 inch thick. And if you wanted to go further, you could like round it with fillets. All right, round these edges so if you're going to drink out of a coffee mug, it's rounded. It's not going to hurt you. All right. So now we have a simple cup, but how do we make it a mug? Right. So the problem is that the kids are going to want to draw on the side surface, but here's the problem with Inventor is that you can't draw on a round surface. There's no way. It won't let you because it doesn't like round surfaces. Also, it's not a flat surface, which is hard to draw on a flat surface. Right. So that's the question, is how I do that. Well, if you think about our origin and where it's at, these surfaces I can draw on, and it's best to kind of start thinking about a surface that would be connected to my shape. So this is kind of the direction we're going in. So we're going to stop here on the coffee mug. Some kids kind of figured it out. They did like this. They drew I had one kid, let me do slice graphic. She did this line tool and did something like this. And then like made another part. So, being creative and trying to figure out the best way you can. This is one way to do it. And I'm not putting any dimensions or anything. So finish, and then extruded it. And then we'll just say symmetrical, and like 0.25 probably is good enough. So she did something like this. I was like, all right, well, that works pretty well. That's not too bad. That's a decent coffee mug and handle. If you filleted it, that would work. But there's an easier way to do it, a lot easier way, and you can round it with the fillets. And I'm just doing this for fun, but I should probably pick this whole thing and round everything. But that's okay. We're gonna cancel that. Anyways, so we're not going to use it that way though. So I'm actually going to get rid of this one. I'm going to press I'm going to delete extrusion 2, right click, delete extrusion 2, and I'm going to delete it sketch. And also those fillets should go away. I'm going to delete this fillet because I don't need that bottom one. So there we go. So we'll leave this for now. We're going to go and save it. And we're going to start a new part. Okay, this is our bell ringer. We're going to start part 1. Right? And we're going to talk about the sweep tool. Okay. So new sketch, new part. We're going to save it. I mean 6.2, 6.1. I did not put that in the right spot. Move it. And open that folder, please. There we go. All right. We're going to change this 6.1 part 1. All right. So we're going to talk about creating a sweep along a path, which is the most common sweep that we're going to make. All right. So in order to make a sweep, you need 2 perpendicular drawings. Okay. So you need a drawing that has an enclosed shape and a drawing that has a path to follow. Okay. So when we look at our planes, we need to draw on the front plane and the right plane, or the front plane and the top plane, or the top plane and the top plane and the right plane could work, right? So what we're going to draw on is we're going to draw on the right side first, draw on the right plane first, and we're going to draw a simple circle, nothing too crazy, right? So in order to create something like a coffee handle, the sweep feature is a great option. It's not a required option, but it's a good option, right? So we're going to start on the right plane. We're going to create a circle that's 0.5 inch in diameter. 0.5. All right. We're not going to extrude it or anything. We're just drawing a circle on the right side. You see my right option, and it's 0.5 in diameter. And we're going to click finish right there. Okay. The next thing that we want to draw on is a perpendicular plane, right? Which is going to be open the origin folder, and we're going to use the front plane as this to work. So when I click front, you can see that now my circle turns into just a line, right? That's what we want. We're going to go ahead and do new sketch on the front view. And now we're going to use something called the spline tool, which is a little weird to use. I'm not going to lie. I'm not a huge fan of it because it's very strange. And here's some advice, okay? Some information on sweeps. If the spline, or if the line you draw is too sharp and too extreme, think of like a roller coaster. Roller coasters have limits to how sharp and how drastic they can turn. Because if they turn too sharp and too drastic, the roller coaster is going to derail, or the structure can break and it'll fail. So the same thing goes with a sweep. is we can't be too extreme, right? So we're going to go under the line option. There's a couple splines, and it's going to be I use spline interpolation. That's the one that I find works the best, right? And the more points you put, the better. Okay. So now we're going to start at the origin. We're going to click once, and now it looks like just a regular line. Okay, until you click again. So we're going to go out a good ways and click again, and then now it's going to round. Okay. And then the more points you put, the better it's going to be. So we'll go back to the x-axis, and we'll click again, and then we'll try to go down a little lower. Click again. We'll go out at like an angle. Click again, and then we'll go back to the origin, or back to the x-axis. Click again, and now you should see this little check mark and a plus sign. I'm going to click the check mark. Okay. So now that we have our spline made, I usually press escape so I can get out of it. So I have these 4 points here, and the more points you put, the more adjustable the spline is. You can adjust the position of that spline. So if it's like too sharp, like this would not work. This would be too extreme. So we want to kind of be something like that. You can adjust it. You can dimension it too if you wanted to. You can widen it, and just you kind of get used to it. It's a little weird of a tool. If you click on the points also, there's these adjustable bar things that pop up, and you can kind of change the extremity of the. So like this would not work. If this was a roller coaster, everyone's dead, right? This doesn't happen. So I press Control Z and I'll go back. So like if you click the point, you can kind of adjust it. You can expand it out. You can shrink it. Also, anything that goes in a loop on itself does not work very well. You can kind of adjust it, tweak it as you need. It is a weird tool to get used to. I'm not gonna lie. I don't particularly like it so much. If you wanted to make sure these, this is a sine wave. You want to make sure it's the same. You could dimension the endpoints. Make sure they're the same on both sides. Let's say that's 0.5, and then make sure this one's the same. If you want to, you don't have to do all this. This is excessive. You want to make sure that the height of it's, it doesn't matter. But this is gonna be perfectly fine. Okay. So we don't care if it's dimension, don't care if it's purple. That's all right. We're going to press finish, right? And now we're going to have this little looking shape. Okay, it looks a little weird right now because there's no material. But basically what we have is we have an enclosed shape and we have a path. The path could also be a straight line. The path could technically be a coil, which is essentially what it is. A coil and a sweep and a revolve are all kind of mixed together. So we're going to go ahead and click sweep, which is right here next to revolve. Control Shift S would work. And it says sweeps one or more sketch profile on a solid body along a selected path to create a feature or body. So notice if you see this little diagram, you can see that they put the actual path on like this rounded corner. So we could have put the sweep at the top of our circle, at the center of our circle, and the bottom of our circle. It doesn't really matter where we locate it at. It's still going to work almost the same. So click sweep, and mine automatically made the sweep. I didn't press anything, but I want to kind of go over that menu. So I'm going to deselect everything. So under profiles, I'm going to click X. Under path, I'm also going to click X, right? So if there's only one enclosed shape, it's going to only highlight one enclosed shape. So we're going to click select profiles. We'll choose our circle. Select curve or edge. We're going to choose our curve. And if it makes the sweep, that means that your curve or edge wasn't too extreme. So let me show you something. So I'm going to go edit sketch 2, and I'm going to make this too extreme. Let's see, we're going to do it like, let's see, like that. All right. And I promise you it's probably going to work because I'm telling you it's not going to work. So sweep. And look, it didn't automatically make it. So it didn't automatically make the sketch, which means that my line is too extreme. There are other options. This is follow path, fixed, and then guide, which we'll talk about those other options later. But sometimes when it doesn't work, you want to try and click between these two options, but nothing is happening, okay? Nothing's happening because my roller coaster is too extreme. Now, maybe if my circle was smaller, it would work, but we need to go and edit sketch 2 and bring that back to normal. So if yours is not working, try to tweak your line a little bit, make it a little bit less extreme or a little easier. Also, the starting point can kind of mess you up. If the starting point's too vertical, That'll also cause some problems. Also, if it goes back on the circle, just make sure it's gradual. It's nothing too crazy. You can also practice this with just a line as well, right? So basically, on the emitter exam, and I am not lying or joking whatsoever. On the emitter exam, this is the part file they're going to give the kids, and they're going to say make a sweep, and it tells them what kind of sweep, follow path or whatever it is. So all they have to do is click sweep, and that's it. It's going to say follow path, which is the first option, and then press OK, and you get this. Mine actually had like a little hole in the end. I don't know why. It's probably because it looped back. See how it loops back on itself? That means mine's probably a little extreme, but it ain't a big deal. So after that point, they'll say, all right, what is the volume of this part? Or what is the surface area of this part? So you go to solid bodies, right click solid one, properties, update, the volume is this, area, mass. And I'm telling you, that's as easy as the question is on the exam. It's that simple, okay? You just click sweep. It automatically should choose your profiles. If it doesn't, you have to select them, and that's it, right? I'm just looking at it. See, now we got it. We did that one. Yeah, there are other options. If you had the sweep, we're going to talk about those other options. But basically, fixed and see, there's the way it changes it. The fixed option will make sure that it's even on either end, and then the follow path option will follow it exactly how it is. So the main thing to pay attention to is on the emitter exam which one it tells you to use, and it'll tell you to follow it. So if we want to do this one is fixed, and you can kind of see how they're the same, but there's no hole anymore because it's making sure that the position of that shape is the same. So pretty simple as far as that goes. All right. Let's look at the next thing. All right. Yeah, those two are pretty much the same option on that one. So that one's. Is there any questions about the sweeps? Well, I like the fixes better. Right, it doesn't have the hole in it. Really weird shape. Are you good? Okay. All right. So let's go and look at the next part. All right. So the next thing we're looking at is a sweep along a path and a guide. All right. So basically what we can do is we can create a sweep that follows two types of paths. All right. So when you're looking at objects that have on one side, it has a straight edge, and on the other side, it has this wavy edge, right? So we can take this little handlebar and we can kind of recreate that using the sweep tool. All right. Now the question is what will our paths look like? Which you can see the path. That's the shape, the path that it follows. But does anybody know what kind of shape looks like we're going to have to use to make this happen? Like what is for instance, for this sweep, the general shape was a circle. That's what followed that path. So what shape would we use here, or what tool would we use here to follow this path on this part 2 right here on the screen?
Slot.
A slot, absolutely. So you see the rounded ends on either end, and it's straight. So we're going to use a slot on this one. So we're going to make a new part. All right. And it doesn't matter which planes we use, but so that we can see the shape clearly, let's use the right side plane to draw our slot, and we use the front plane to draw our paths. Okay. So we're going to do a new sketch, save it. This is part 2. Part 2. All right. We're going to do a sketch on the right plane. And if I had to guess, I would say that the total length of this is like from end to end is an inch, maybe. I don't know. And no, an inch wide, 2 inches long. Let's do that. Right. So under rectangle, we're going to go to, I'm going to do a center point slot. And I'm just going to draw it out. I'm going to draw it vertical. So center point slot, go to the origin, click up, click again, and just expand it. I'm not going to actually, I don't typically dimension this one how I want it. So the width of it, I was saying, is going to be, actually this is the depth of it. So dimension the depth, we'll say is an inch. All right. And then the height of it, we'll dimension to be 2 inches. Just like that. That's good. That looks roughly correct. It doesn't have to be perfect. We're not submitting this for any research purposes or anything. So, all right, there we go. So now we have our profile that we're going to use. So now we need to draw a perpendicular sketch that connects the top of our profile and the bottom of our profile, right? So you notice from the top, if we look at it, it just goes straight. It's just straight across. But the bottom is going to have this wavy spot for our fingers, all right? So we're going to do a new sketch, and we do this on the front view now. All right, what I'm going to do is I'm going to do project geometry, and I'm going to touch the top of the object. So I want to use the top point here. Can I do that? I'm probably just going to have to select the top here and the bottom here. There we go, just like that. Okay. And now I'm going to do a line, just a regular line. And I'm going to estimate that this line is roughly about as wide as a hand. My hand is about 3 3/4 of an inch wide. So we'll say it's going to be 4 inches. We'll do 4 inches long. Okay, so from the top of it, I'm going to do a line that's horizontal, and it's going to be 4 inches long. Just like that. So this right here is going to be the width of our handlebar. And if it's kid's handlebar, it might be a little smaller. I don't know. Usually it's going to stick out a little bit. So 4 inches seems pretty good. Seems decent enough. Right? So now we want to go ahead and make our spline tool and have it to where you can see the first part, it kind of goes down, and then we're going to do the best we can to make some grips on this one. I promise you it's not easy. Sometimes dividing this up into, let's see, 1, 2, 3, 4 sections might help. You can see the last part kind of falls off over here. So what I do is I'll do the line tool and then construction line, and I'll kind of like make a line I know that's going to be, I know it's going to end right there, so we can connect it right there. We can start and go up and then down, up and down, and do your best to make 4 incremental points, but it's not easy, I promise you. So I'm going to turn off my construction line, and I'm going to go ahead and do spline interpolation. I'm going to start here, and I'm going to go across a little bit, and I'm going to go up. Let's see, about, make sure I'm doing proportionally correct. About right there is, and that dang check mark thing kind of gets in my way. Just do your best. Like I said, the more points you put, typically the more adjustable it can be. Mine is looking a little wonky. I don't like this. It gets kind of crazy, so I'm just doing the best. I'm going to adjust all of this in a second to make it look a little better. Should have put a point there. That's all right. I can adjust them. There's 1, 2, 3. I'm going to go ahead and finish it. Now that looks kind of crazy, but we can adjust them. We can kind of widen them out. It looks a little better. Press escape, open the tool. Should be able to adjust this guy right here. Why my adjust point's not popping up? All right, I don't know why. Can kind of move that up a little bit. Kind of got a little crazy at the end for me. I don't know how you guys are doing with this one, but a little better. I'm trying to shift everything. Something like that looks decent. It seems like my fingers got a little bigger as we went, so I can kind of move that over a little bit. It doesn't need to be perfect. It just needs to be relatively right. So 1, 2, 3, 4. I should have put another point down here. You can see that the ones that look kind of pretty good, they have 2 points kind of spacing them out, and I forgot to put a second point there. So that's kind of goof up right there on my part, but that looks decently enough. Probably could expand this a little wider. Like let's set it to maybe 5 inches and see if it, yeah, 5 inches gives us a little more space. Looks a little nicer. So because I use this construction line and I connected it, when I change this value, it'll adjust my spline as well. So just kind of a design intent there where it worked out. So that's roughly good enough. It doesn't need to be perfect. So just do your best to make that. And then we're going to go ahead and finish this. So now we can see the idea, right? You see the path of it. So we're going to go ahead and do sweep. It automatically chooses your circle or your semicircle, your slot right here. You're going to choose the path of the top. And then you need to go ahead and choose guide. And I'm going to choose our second option, which is going to be the bottom. And this one isn't going to make because probably something wrong with my sweep, my path here. So if you see, I don't know if you guys can see this, but it looks like it's choosing these lines here. There's this line that's getting selected. It's like a little dark, a little like different shade of blue. So what's happening is it's going up and across. So when I did project geometry, it connected those lines together and it's causing my sweep to try and go at a right angle, and it doesn't like that. So I'm going to have to press cancel. And it's these lines right here, these two project geometry lines. I'm just going to delete them. So I'm going to edit sketch 2. I'm going to move my drawing over to where I can see those again. I'm going to click on the project geometry lines and just delete, or you can even turn them into construction lines. How about let's do that? Click on them and turn them into construction lines, and then that'll make it to where they won't give us any problems. That's better. So when you click on a line and then click on the construction line button, it'll turn it into a construction line, which is a super useful tool if you have geometry that's causing you issues and you don't want to get rid of it and it'll mess your drawings up. So let's go ahead and try that again. Sweep. And choose this top edge. You can see it follows that, but now it follows the path. Before it didn't even follow that path, but I want to use a guide, and I'm going to choose the bottom line as that guide. And then I'm going to press OK. All right, and that's kind of like it. You know, it's close enough. I think it might work. You know, you can maybe test on some handlebars. If you wanted to do, you can do a circle over here. Do a circle right here and cut it through, and then go up to like the end point. That would hold for the handlebar, you know, for the handlebar. But it is what's kind of funny though is it's like following from the side profile. It's not flat, so maybe I need to go ahead and edit the sweep and change it. Is there a way to change the profile? I don't know why it's following it like that. It's kind of weird, but I mean that's close enough, I guess. Let's see if I choose this first. I don't think it matters. Yeah, it doesn't matter. I don't know why it's doing that. It's kind of strange. X scaling. So I clicked X scaling, and what's this? No scaling at all. So press OK. All right, that just made it a block. Okay. Let's do X scaling. So X scaling made it flat. All right, that's weird. Okay, that looks okay. So this right here, these options right here, profile scaling, this one says X and Y scaling. So I guess it's letting the X and Y. So basically what's happening is I think the X and Y dimensions are following that path, whereas this is just the X path, which is the elongated path that it's following. So I just checked. It doesn't matter though. You don't have to modify that, but that's just a difference. So if I just chose the default Y scaling, what's happening is not only is the top of it, the bottom of it following it, but also like the side profiles following it. So it's like repeating this feature at the top of it, which is, you know, it doesn't affect me very much wise. But if I wanted this to be more accurate and I added the sweep, I would choose just X scaling. And that only allows it to follow in the X direction and not the Y direction. But I mean, it's not really that much of a difference still. So it's more flat now, which is more, you know, closer to this. But either one's fine. Is everybody okay with this one? All right. That's that one. Yeah, we could have also like, instead of, in this case, we could have made it hollow also. So if we would have made, I do want to show, I want to show this one. So I've learned, I recently kind of used this a little bit. So we're going to edit sketch 1. So there is a tool. So in this case, in the drawing, it shows there's 2 slots because they're making it hollowed out. So if we wanted to do that, we would just need to add another slot in the middle of this. So you can do the same slot, click it again, and then add it in the middle and do something like that. That would work as well. But there's an actual tool that I thought was pretty neat called Offset. So Offset duplicates sketch geometry. And I've tried to use this. Now, the more complicated the drawings are, the harder it is for this to work. but it's like an easier way to duplicate the same geometry and make it just like a little smaller. So you click offset and you click this, you can kind of make an adjustable slot, and it's like so much easier to make this. So you can kind of make it, let's do something like that, would be good. And then we don't need to dimension it. We can dimension it from the edge, see from here to here. Let's just do 0.1. Cannot be evaluated, but it just, 0.1, no, 0.1, there we go. All right, and then now what we can do is when I press finish, it's not going to reflect that in my shape. So to make it reflect in the shape, just double click sweep 1, and then under profile, we'll deselect it, and we'll just go ahead and select this smaller profile. And then it'll make that change. You could have technically shelled it too, probably, but I wanted to demonstrate that offset tool because I think it's really valuable. It's a really good tool. Now it's hollow. So the shell option would also work for that too. So let me show that too. So press Control Z. And then if you go to shell and then click this face, that would also do the same thing, but it would not be hollow. It would stop on that end, right? So shelling it out. So those are two options that you could do to make that opening. You could also do the circular opening. That's kind of your option as well, to do that one. Okay. There might be questions about the sweep tool, but as far as Inventor goes, it's super easy question. Any questions on sweep? Everybody doing okay? All right, I get one thumbs up. That's good. Okay. All right. All right. So now what we're gonna do is we're gonna look at making our coffee mug with the sweep tool. All right. So we're gonna make this little cup here. You can see it has an angle at 0.8 at 80 degrees, 80-degree angle there. You could also position it from the other side as well. Now it says shell thickness, so we use the shell tool. I would just do you could probably do this with the revolve tool also would be an option, but you can just make a circular cylinder that's 3.5 in diameter, extrude it, and then use some called a taper. So we're gonna do that one. So we're gonna do a home, do a new part. We're gonna draw a new sketch on the top view. Also, one thing to show as well is if you want to do extrude, it would automatically do a new sketch. So it's the same thing. We're going to rotate the view cube. Doesn't matter for this one because it's going to be a circle. So a 3.5-inch circle. We're going to extrude this 5 inches. Extrude 5 inches. All right, and then we're going to do a taper. Okay, so now, looking at this taper angle, it says 80 degrees. All right, that's the exterior taper angle. So now if we do an 80-degree taper, that's not right by any means, right? That's making a flying saucer now, right? So now maybe I need to flip the taper to a -80. That's definitely not right either, okay? So what we have to process here is what is the actual taper angle that we need? Well, if it was straight up and down like we had it before, straight up and down, that's a 90-degree angle. And we're saying this angle is 80 degrees. So really the taper angle that we actually have is just a 10-degree taper. Just like that. So 80, plus 10 is 90. Originally it was 90. We adjusted it out 10 degrees to hit an 80-degree angle. So it's a 10-degree taper. So, okay. And then we use the shell command. And the shell thickness is 0.125. Shell thickness default is, in this case, was 0.1, but it is 0.125 as a default. And then we're going to choose the top surface. Select surface. I chose my thickness, my shell thickness, to 0.125, and then I have to click face 1, and then click there, and then press OK. And now I have a cup. Right. I'm going to go ahead and save this as this is part 3. It's actually an adjustment of the bell ringer, but it's part 3. But to make sure everyone has the same exact cup, same exact process, same exact everything, I'm going to showcase how to make a coffee mug handle with the sweep option. Okay. Remember, when we're doing the sweep, we need two perpendicular planes. One is going to be a circular object, and the other one is going to be our curved object. So we're going to do a new sketch. We'll do on the front, let's see, the right side. This is where our material will go. We'll do a new sketch on the right side. All right, I'm going to go ahead and do slice graphic. And here's the thing. It's for my coffee mug. It needs to go over, it needs to be able to connect to the object, right? So in this case, all I want to draw on is right here. And that's actually not a very good spot to draw in the middle, okay? So what I'm going to do is I'm going to press Control Z, and I'm going to show you a new technique, okay? So we're going to go back to we're going to draw on the front view, actually. So we're going to draw on the right side. We're going to start with our path, okay? Start on the right side. We're going to start with our path, and all I want that path to do is to stick out just a little bit, right? So we're going to do a spline. We're going to do a path a little bit, and then we're going to go into the shape. So it's going to go out, and we're going to start curving our mug. And then we'll press finish, and I'm going to tweak it a little bit. And that's a pretty decent coffee mug, I would say, coffee mug handle. So I want to draw on wherever the end of my spline is, okay? But I can only draw on a plane, and it needs to be a perpendicular plane, okay? So the question is how do I do that? How do I draw specifically on that point? Well, we haven't talked about it yet, and we're going to go ahead and talk about it now, is we're going to be talking about adding a plane on a point, okay? So we have an option to put planes where we need them to. So if you look in the 3D model tab after you've made this spline, you see this plane option right here under work features. There's a plane option. So it creates a construction plane that is attached parametrically to other objects. You can connect it to a surface. You can connect it to an endpoint. Then there's other options too. If you click the drop down option, there's a bunch of plane options. There's an offset from a plane. Like we can offset it from a surface or from like an existing plane. It can be parallel through a point and a plane. So like you have a point and a plane. Mid plane between two planes. This guy is the most useful out of all of them. You'll understand later. Mid plane of a torus. Angle to a plane around an edge. 3 point. I haven't even used these two, but I've used tangent through a surface and an edge, and then tangent to a surface through a point. Tangent to a surface parallel to a plane. Like there's a lot of really valuable options here. We're going to do just a regular plane button, just the regular default plane button. And once you have that plane button activated, you should see a plane option on your mouse. And then what we're going to do is we're going to click the end point of our spline. And then you have to click again when it pops up. So now I click the point, and now it pops up. I got to click it again, and now it put a plane on the end of my spline. Let me show that one more time, okay? So I click the regular plane option, and then I'm going to go ahead and click the end point of my spline. No, that's not what I wanted. Sometimes you wait too long, a command window will pop up. And then now it's still not there, but I got to click it. So when it highlights, so I basically got to click my spline line now. So look, so I'm going to click work plane, click the endpoint, and then I'm going to click the spline. All right, and it adds my work plane there. Okay, so now I have a new work plane, and it's a randomly placed work plane, right? So now we can click our work plane. Now you see in the model menu work plane 1. So you're going to click work plane 1, and then you can click new sketch. And now it's going to draw in a really weird space. Okay. So now I can't see where I'm drawing at. So I'm going to do slice graphic. And watch what slice graphic's going to do this time. It's going to be a little weird. It's going to cut into our shape, because this is the position that this plane is going to cut into if it's going to touch the material of our object. Okay. It is a weird surface, but this is kind of like let me do F4 and move it around so you can see it better. So it's kind of, that surface is kind of the surface that we're cutting off to temporarily view it. Okay. See if I can get back to that view. There we go. It's close enough. All right. So now there's actually and then you can, in Inventor, all right. So in Inventor, the Inventor exam, it's going to have this scenario like this. There's going to be this plane in a random curved object. And what it's going to ask you, it's going to say project cutting edges which this is not for the coffee mug handle. This is just a tested inventor question that's going to be helpful. It's going to say project cutting edges. So what's really good is under project geometry, there's this project cutting edges thing. So what I tell the kids periodically throughout the year, and I forget to emphasize it in this class, is that when we use slice graphic, it pairs extremely well with project cutting edges and project geometry. Those are like those three things are really good. For this one, project cutting edges. So it's going to project the edges that the plane is physically going to cut through. So whatever material that gets removed when we do slice graphic, it's going to project that cutting edge. So you're going to click project cutting edges, and it's going to make this shape. So on the inventor exam, it's going to say, basically you're going to have a sketch that looks just like this. So watch, I'm going to click finish sketch. It's going to look just like this. You see how you can see this little loop here, or this little line, and it's on sketch 3. They're going to say, edit sketch 3, use slice graphic, project cutting edges. Boom, we already did it. And it says use region properties to find the loop length of that shape. So region properties is going to be under tools, measure, region properties, and then you just select this option. And the loop length means the perimeter. Now in this case, you can't use the measure tool because it's not an actual physical shape. It's only a temporary cutout, right? But you have to use region properties. So we click the loop that we wanted, we click calculate, and the loop length is 8.631. This is a tested question, and I just wanted to kind of touch on it and go over it because it's extremely valuable to know. But it's not relating actually to this option here, okay? So now where it says project cutting edges, I want to delete it so I don't have any issues. I'm going to right click and delete it. And now I just have my plane. So that was just a demonstration of how to use that one, okay? So sorry if I lost you a little bit. It is a tested question, so I want to go over it. All right, so now we're going to go ahead and put our shape that we want our coffee mug handle to be. So you can pick whatever shape you want, all right? I don't even care what it is. You want to make your coffee mug handle, you want to make it a hexagon, a rectangle, a triangle. I thought an ellipse is a really good option for that one. So if you go to sketch and under circle, an ellipse is probably like a better shape sometimes for a coffee mug. That's typically what they are. If you wanted to play around with the polygon tool, go for it. I'm going to do an ellipse, and I'm going to go and draw it on the center point. You see it automatically snaps. And it's not giving me a dimension option, so we'll just make the ellipse rough, something like that. I'll make it a little bit bigger, so you can see a little better, or don't expand. All right, I don't know why it won't let me. Let me see if I can set the value. I can't dimension it. I don't want that. All right, dimensioning ellipse is kind of annoying. Okay, well, that's how it's going to be. It's going to be weird. I can probably make it a little bit there. All right, so now we click Finish Sketch. And now if we look around at our object, you hold F4, there we go. You can see that that ellipse is connected to the end of my spline, right? Then we're going to do Sweep, and it automatically selected it, but Rail was the last option, so I'm just choose Fixed or Guide. There we go. Follow Path is what worked for me. Follow Path, and then press OK. Sometimes this right here, is it fixed? Yeah, fixed, but follow path worked for me. It originally selected guide, but I want to go to follow path. Press OK. Now I have a coffee mug handle, but here's the problem is that it's still sticking out inside the shape, and that is definitely not going to be a good quality coffee mug. So there is a way to get rid of them. So let me show you. So we want to go ahead and I'm going to turn the visibility off on that work plane. So if you right click work plane 1 and go down to visibility, you can turn it off. That way it's not there anymore. There is an option that's called remove faces, delete face right here. This delete face option is a very valuable tool. Okay, so click delete face, and what it's going to do is it's going to delete the faces that you don't want. So I don't want these faces right here. Okay, so if I click here, there we go, and then click that, and then press OK, it'll delete it. But here's the problem is that there's still a hole there. We don't want that hole to get there. So if you press Control Z and then do delete face again, there's an option that says heal remaining faces. So just click that. And then now if you try it again, and press OK, it won't have a hole in it. It'll just smooth it out. So click delete face right here. Make sure heal remaining faces is selected. Choose this, then rotate around. Zoom in, choose that. Press OK. And now we have a pretty smooth coffee mug that my handle looks like it would snap, but you know, good enough. All right, any questions on sweeps? So like I was saying, if there's any questions, please ask them now. But on the inventor exam, what I was trying to say is like the sweep question is as simple as like the first thing that we did, this right here. Literally, it's going to be just like this. I don't want to delete the sketch. It's going to be, all right, open, all right, here's part 1. Make a sweep and use the follow path option or use the fixed path option. Literally, click sweep. It automatically selects it. It said it wanted to do follow path option. So we'll leave that. Press OK. What is the mass area volume? Then you do solid bodies. Right click solid 1. And then properties, update. All right, there is another one I'll demonstrate too. It's actually on the inventor practice test. We don't talk about sweep cuts. Okay, so let me do a. I'm just gonna make. You don't have to make this part. I just want to demonstrate real quick. But if you want to, I'm doing a new part. I did a new sketch on the top view. I'm doing a rectangle, 2-point center rectangle. That is a 4x4. All right, and I'm gonna extrude it. I'm gonna extrude it like a half inch. All right. Now, what I'm going to do is I'm going to draw on this front plane. I'm going to draw a circle on the top edge here. That's going to be 0.5. And then I'm going to make a path. I'm going to make a path on the top surface. That's going to connect to my circle. So I'm going to do a spline. You don't have to make this one. I'm just showing you something. They need to be connected. There we go. Let me adjust this a little bit. All right, press. There we go. All right, so there's a question on the inventor exam that looks just like this. Okay, and I have a practice question that I think I put on the practice test too. It's going to say use the spline to cut a path into the object. So you just do spline. That's not spline, sweep. And then it's going to choose that sweep, and then we're going to choose our path, which is this right here. And then we're going to change it from not a joint, because if I press OK, it's going to add material. We're going to do a cut, and then press OK, and it's going to cut a little path out of it. Right now, my line doesn't look like it went all the way to the end of it. That's probably why it doesn't show it from the endpoint. But that is a tested question, just like that. So those are the two sweep questions: is this question and what I just made. That's literally the only sweep questions that we have on the test. So it's really not bad. So pretty simple questions. Those are gimme point questions, right? Okay. So let's move on to the next thing. We got that right there. We did the sweep, yada yada. Perfect. All right. Any questions on sweeps? Am I doing okay on sweeps? I have 6.2. Quiz. I'm going to close these out. All right. All right. Next thing is 6.2 lofts. All right. Let's open the teacher notes on that one. So we'll go ahead and we can save everything. Close this out. I don't need to save that. That one, sure. Right. Okay. So now we're going to look at lofts. Lofts are not bad either. They're very similar to sweeps. Okay, they're kind of similar. The only difference is, now I'll say it in a second. I don't want to give it away just yet. All right, it says Bellringer, without using the internet or to Google it, create a 4-sided pyramid. So it has a square base that's 2x2 and it's 2 inches tall. Use the function to drive all but one of the dimension parameters. Okay, so let's do a new part. Standard IPT. We're going to save this. This is going to be 6.2 Bellringer. All right. So I'll give you 3 minutes to see if you can make a pyramid in Inventor. 2x2 base, 2 inches tall. Make a pyramid. You can use any of the skills that we previously taught, or you can experiment with possibly new skills. All right, so 211 will start. Josh, see a thumbs up. You got it?
Yes, sir.
How'd you make it? How'd you make your pyramid?
Drew a square, and then I put a selected point on a different plane, second sketch, and I made a point 2 inches above the center of the pyramid of the square, and then I just lofted from the base to the point.
You're a cheater. I didn't say use the loft tool. That's okay. I'm just kidding.
You said experiment.
Yes. So if the students are paying attention to their board and to their agendas, they should see that we're using the loft tool. All right. So yeah, no, I'm just joking. But no, this is what the kids are going to do because they don't pay attention. They're going to they're going to do the square on the bottom. No problem. And I haven't taught you guys how to use the loft tool yet. So maybe you don't know how to use it. So you're trying to figure out whatever way you can do it. And they know that if they extrude it 2 inches, they like the taper. They've used the taper option. And they'll start experimenting with the taper. They'll do like a 15-degree taper. And that's the wrong way, so we need a negative taper. So that looks like a pyramid. It's getting close, right? But it's not a pointed end. So like, oh, well, I know it needs to be a little bit more. So let's do a 20-degree taper. 20. And it's close, so let's do 25. All right, it's almost there, right? Almost there. So we're experimenting some more. So we'll do a 26-degree taper. And if you zoom in, it's still flat, so we'll do 27. Also, keep in mind this little gold ball up here at the top, that's my 2-inch marker. We did 27. It makes the pyramid, but it's too short. You know, it's not exactly 2 inches tall. So they're like, oh, well, I know it's in between 26 and 27. The irony there. So they're like, well, let's just do 26.5. And that's close, but I think it's still a flat end on it. Still flat. So let's do 26.8. All right, it's too short. 7. Still too short. So 6. All right. So you can see that we're getting a pyramid here. We're getting it, but it's not exactly 2 inches tall. So there is probably a magical decimal that you could probably find that would give you the right value. But realistically, that is not practical in a real life scenario, especially if you're timed on that one. So what you have to think about is what is a pyramid essentially? A pyramid is essentially a base and a point, and the edges of that base are being stretched to that point. Okay, so I'm going to delete extrusion 1, but I'm not going to delete the sketch. Okay, so here's what we're going to use. We're going to use the loft tool. Okay, so the loft tool is similar to the sweep tool except instead of using a perpendicular plane, you're going to use two parallel planes. And the question is there a parallel plane to the top view? And the answer is no. That's perpendicular. That's perpendicular. That's perpendicular. I mean, itself is parallel to it, but it's not. So we're going to have to add a plane that is going to be parallel to that plane, and it needs to be exactly 2 inches above it. So if you go to your plane tab, this time we're going to choose offset from plane. I guess also, is there a parallel? Yeah, offset from plane. And we're going to choose our top plane that we drew on. And we're going to set that distance to 2 inches. All right. There we go. So now this is the height of our pyramid. So we're going to draw on this plane. And then now we're going to put a point. So we don't use it a ton, but it's actually a pretty useful tool. And if you go into the little create ribbon, there's a point option right there, point. And we're just going to put a point at the origin. You could also project geometry the origin. That would also work. And we're going to click finish sketch. So now you should see this. You should see your plane, and you see a square at the bottom, and then there's a point at the top. And then now we're going to do loft. And this is where the menu is a little weird looking. But we're going to choose, basically we just choose our 2 sketches, okay? We'll choose sketch 1, and then we'll choose sketch 2. And then, boom, you'll see this preview right here. And then we just press OK. We don't worry about anything else. There's no other options that I need to adjust. And now I have my pyramid. We're going to right-click Work Plane 1, turn off visibility, and now we have a perfect 2-inch pyramid from top to bottom, okay? And that's about the only way to make a legit pyramid in Inventor.
Out of curiosity, are you just showing them the work plane extra stuff just for practice?
They will need to use this later on. So like we're
Okay.
kind of building this into our topic. So like when we get to, for sure in assemblies, we see work planes. There's also like a work plane question on the Inventor exam. And now that we've done work planes, it makes them, there's like application wise, makes it a little easier to do certain things with it, to make stuff. So
Okay, I just want to make sure. I mean, you don't necessarily have to make the work plane to do that.
No, we need to. Work planes is incorporated into the curriculum. Yes, we need to teach about work planes because we're going to talk about between 2 plane work planes as well. Because like that one, like especially for the mirroring tool, to put a work plane in between 2 planes is going to make a huge difference. All right, that's good. All right, it says download the part. So it says 9.2. This should be 6.2. I didn't edit that from the classroom. So you guys in the Google Classroom, there is a file for you guys to download. It is 6.2 part 1 under your classwork tab, and we're on day 9. All right, so it's 6.2 part 1. You guys go ahead and download that now if you haven't already done so. And it's going to look like, click it. All these things out the way. It's going to look like this. All right. And there is a question similar to this on the Inventor exam. All right, let's say you want to loft these 2 shapes together, but you accidentally sketch the 2 shapes on the same plane, right? In this case, the XY plane. What we want to do is we want to create a new plane and then copy the sketch to a new plane, right? And this is a very valuable skill as well, is that we can copy sketches. And we don't explicitly talk about this because I'm not trying to share too much information as we go, but it makes life a good bit easier. So what we're going to do is we're going to do an offset plane. So plane, offset plane, and we're going to offset it from the front plane. So we have to go into our origin folder and do the front plane, and we're going to offset it 0.5, just like that, okay? And what we want to do is we want to copy one of these sketches to that work plane, right? So we're going to copy the smaller part, the smaller sketch, which is the rectangle. We're going to copy the rectangle to this work plane. What we're going to do is we're going to click sketch 2, All right, it's highlighted. We're going to press Control C to copy it. We're going to click work plane 1 and press Control V. And it's going to copy a sketch to another plane. And you can do this periodically throughout your throughout the Inventor like options. Let me demonstrate that one more time. We're going to click Sketch 2, press Control C, click work plane 1, press Control V. Just like that. Now, what's going to happen is now we have 3 sketches, and it's going to be kind of confusing. The best thing to do is to delete this sketch 2, right? Delete the sketch 2. That way there's no confusion on that one. Now we can loft it. Loft, sketch 1, sketch 2, sketch 3 now, and then press OK, and you have a little knob there. I'm going to turn the visibility off on my work plane so you can see the shape. So pretty straightforward, nice little copy tool. That's pretty good. Okay. And it says, what do we want to change the material to something other than default, the generic default? So if we wanted to change this to steel or something, up here at the top, mine has these double arrows because the menu is condensed. But if you go to generic and you wanted to change it to steel, or there's all kinds of different materials and stuff. But it says stainless steel. There's a lot of stainless steels. Just do stainless steel at the top. It'll change it to stainless steel. And it says to change your material from generic to stainless steel. We did that, yada, yada. It also, the main thing the kids need to know is that the one thing that it's going to change as far as your values go, your properties, is it's only going to change the mass. It's not going to change anything else. Like the size of the shape is the same. It's just like the mass of it's going to change. So the volume and area won't change, but the mass is. So right now the mass is 0.040. If I go over here and change it back to generic, there's generic right there. And then check the mass area and the volume again. It's 0.005. So it's a substantial change as far as like value goes on that one. So just note that one on that. And then it says, what is the center of gravity in the Z direction? So another thing too, that's also in iProperties. The kids always forget that for some reason. The center of gravity is 0.186 in the Z direction. So anything that asks you for general information of the entire part is always iProperties. All right, what does this mean? So we know that it's extending more in the Z direction than anything. All right. Okay, so we're going to move on to the next thing. Lofting using multiple sketches. So this is this gets a little tricky, okay? And the homework on this one is the kids are going to make a water bottle, and I'm going to demonstrate kind of how we would do that on this one. So let's go ahead and do a new part. And let's think about how we could make a doorknob, right? So essentially, what is a doorknob a combination of? Essentially. Oh, tell me what a doorknob technically is a combination of.
Bunch of cylinders.
A bunch of cylinders, a bunch of circles. If you think of a 3D printer and how a 3D printer does, if you slice it into like a million different pieces, or let's say in this case it would probably be like 70 layers, you could see that there's different circle sizes on this thing, and they're all in parallel. So really what we want to do is we want to make a bunch of circles, right? And then we can just stack them, and then we can decrease and increase the size of those circles, and it's going to follow that path of our doorknob, okay? So if we look at it, we have an outside circle, and then it goes into like a smaller circle, and then that funnels to an even smaller circle, and then it's going to transition us into a doorknob. So you first need to create multiple planes, each with a sketch on the plane, and then loft them together. In this case, start on the top plane with a 2-inch circle. So we're going to do a new sketch on the top plane, rotate it. It doesn't matter. It's circles. We're going to start with a 2-inch circle. All right. Which I would say that, like, realistically, it's a little bit bigger if we go with the base and then work our way in. But we're just going to kind of demonstrate this, how it goes. All right. And then what we want is you can work. Now, the more circles that you include, the more accurate the dimensions are, the better this is going to look. But for the most part, we're just kind of giving like a general idea of it. So, and then we're going to add 3 new work planes, each a 1/2 inch apart. Okay. So we're going to do a work plane, an offset from plane, you can even offset it from the sketch. Thought you could, maybe you can. Origin folder, the top plane right here. We're going to do 0.5. We're going to do another one. Offset from plane. From this one, 0.5. And from this one, 0.5. So we have right here, if we look at it, we have 4 planes that we are technically the top plane and then these offset planes. Okay. So these 3 planes we're going to kind of try and build 2. We're going to try and build our doorknob around those 2 planes. All right, so you can reference them from the XD plane, making them 0.5, 1, and 1.5, or just a 1/2 inch apart from each other. All right, so on your XD plane, you have that 2-inch circle. On the work plane closest to your top plane, draw a circle that's 1.5 in diameter. So it's going to be smaller than our main circle. So we're going to click this one, this work plane, do a new sketch, and we're going to draw a circle that's going to be 1.5. Then press finish. Now you can see we're kind of working our way smaller. All right. And then on the next circle, on the next plane above that one, we're going to draw a 1-inch circle. Press finish sketch. All right. And then on the next one, I missed it. So this one's actually supposed to be a 3-inch circle. Change the dimension right there, 3 inches. Now that's a new thing. Before, I don't know if you guys saw that, but I'm not in the sketch, but I can double click that dimension and I can change it right there. Usually used to you had to go into the sketch. And then on the very, very top one is going to be a 1-inch circle. This one's going to be a 1-inch circle. Then press finish. And now if you kind of look at it and move your shape around, you can kind of see the general idea of like this is kind of like what the doorknob is looking like. And then we're going to go ahead and loft that together. So click loft. And then we're going to click each sketch. Click the first one. Click the second one. Third one. Fourth one. And press OK. Then I'm going to turn the visibility off on these work planes. They're all actually like compounded together, which is kind of weird. And now if we look at it, this is, pretty decent looking doorknob. Not too bad. So the loft tool, if you think about an object that's in a linear direction and then you kind of slice it up into pieces and you think about what is the general shape of it, that's what you're going to get. All right, let's see. Draw circles 1 inch. Now loft it in order to do. After you've created a loft, your work plane, make it visible. We just did that. Turn the visibility off. And then let's check the surface area. You should have 21.293. So solid bodies, right click solid 1, properties, update, and that's my area. Okay, that's the surface area of the entire shape. All right. And that should be it for lofts. Pretty straightforward. The assignment the kids would do is they would make a water bottle. So I'm not sure which one I'm assigned to you guys. Probably not going to be that one, but let's see, we're not done yet. We're almost done. We're not there. So it'd be sweep and rib homework. That's all you're going to have to do on this one. All right. So that's 6.2. And typically these only take me like a day to get through. They're really not bad. All right. Any questions on the loft, guys? And then look at ribs. All right. So now there's this part. We've actually seen it. It is in the Google Classroom. It is a 6.3 part. Let's go 6.3 part 2. I don't want it's part 2. Is that correct? Let me see. Make sure that's right. Nope, that's the homework. 6.3 bell ringer. 6.3 bell ringer, and there's 6.3 part 2. Just go ahead and download that bell ringer, please. Go ahead and open it. And here we go. Oh, this is where we're going to use those other planes. So this is going to be a demonstration for you, Josh. So we'll look at it. All right. So now there is a option on our scenario where what the bell ringer says download the part from the classroom, add the triangular shaped ribs to this object, and so that the final object looks like the image below. The rib is 0.25 inches thick. Okay, so and the kids are probably going to draw. They're going to try and draw the triangular shape. This is what they're going to do. They'll do a new sketch on this L shape. If they're clever, they'll do project geometry. They'll use this edge. This edge, we're going to draw a line here to here. And then we're going to dimension that line. It says 0.25 from the top. And then 0.25 from the edge. And then they're going to extrude it. We got to flip the direction, and it's 0.25. And then the best thing to do is to mirror it to the other side, right? So if we try to do the mirror tool, we can choose what we want to mirror the rib. And then our mirror plane, if we try to use our, if you look at it, if we try to use our planes, it's not going to work, right? We can't mirror it over there. That's not where we want it, okay? So that's for the kid. Then they'll have to figure out how they're going to get it. So more than likely, they flipped it around and they drew it again because they couldn't figure out how to mirror it. But I think in my PowerPoint, I'm like, you have to mirror it. You don't have a choice to mirror it. And maybe some of them figure it out, some of them don't. But I want to demonstrate the rib tool, and then I want to show you how to mirror it, okay? So this is a good way to do it, just like this one. You could extrude it, that's fine. But the rib tool is useful, and all you need is a line, okay? So the rib tool is that in this case, in taking this extrusion off, all we need is this line right here to make a rib. And a rib, the actual rib function of it is a support piece, okay? So now if you don't have anything to support, you can't make a rib. You can make an extrusion on anything, but you can't make a rib. So all you need is a line, right? So rib, and basically I just took off that extrusion. You're going to choose the line. Now there's two options, okay? There's normal to sketch plane. So it's gonna kind of follow the path of the sketch plane, and this one is parallel to sketch plane, so it's gonna be side by side of the sketch plane. And I'm gonna go ahead and be a little honest right now. I get confused between the two options. So typically, if one doesn't work, I click through all the options of the second one. So I'm gonna start with the default, and then right here it says choose your profile or choose the line. If it works, awesome. If it doesn't work, kind of play around with these three options. So if you choose this option or this option, and then there's also different directions as well. So this one's not going to work. So we actually want to be parallel to the plane that we sketched on, which makes more sense. We don't want to actually go down across the plane. So we're going to choose the second option, and we're going to choose symmetrical. But I think the profile direction's wrong. The direction 2 should work. Okay, there we go. So symmetrical is not going to work because there's open space here and there's nothing to support, right? So if I choose these other directions, this one works. Okay, so this one just changes the direction that they're going to appear out of. So this one, I don't understand. I think it goes maybe the other way. I'm not sure. But see, I chose direction 2. I'm in parallel to sketch plane, and then I chose the flipped option, the second option. That's going to actually put us in the right spacing that we need, and then 0.25 is the thickness of the rib. Okay, so ribs are weird because you got to kind of think about the drawing plane. So let's think of the plane that we drew on. It's basically this surface right here is my drawing plane, and I want the rib to follow that direction, right? I want it to actually move in the same path as the drawing plane. That is parallel to it. So that's why the parallel option worked. Okay, we couldn't use symmetrical because symmetrical, there's nothing to support over here, so it's not going to work. This option right here flips the direction to make it go over here only, and we cannot support anything that's not there. So, and then direction 1 and direction 2, they're kind of. I think direction 1 will flip it over here. You can see I think it actually makes it go on this side of the shape versus on this side. I don't know. It's kind of weird. So second option. And then you could also make it to where it's empty. Like it's like if you ever think of like actually supporting like a floating countertops or whatever, that's kind of like the support piece they use. They don't use it. I mean, you can use a solid block too, but this works as well. We want the solid block on that one. So all you need is a line. That's it. A line that connects the two surfaces that you want to support. All right. Now to mirror it, we need a plane in the middle of our shape. There is no plane in the middle of our shape, though. If we look at our origin, that's the plane I need is the YZ plane. So we have two options. We can do an offset plane from the YZ plane, or we can do what I think is the most useful, is a mid plane between two planes. So mid plane between two planes right here. And what you're gonna do is you choose this front surface, flip the shape around, choose this surface, and it's gonna throw a plane in the middle of your shape. Exactly where you need it. Because remember, when we mirror, we need a mirror plane on 3D model mode. So do mirror. We're going to choose our rib. We're going to choose our mirror plane, which is going to be this plane. And then we're going to press OK. And then we're going to take the visibility off on our work plane. And now you have this shape right here. All right. Ribs are, I don't know, they're okay. The emitter test, the rib is so easy. It's literally, it already has the line made for you. You literally just have to say, use the rib command and follow the instructions, and it's that simple. All right. So like this is an example. So we're gonna open. Is this where we open a part, or we make it in order to build? So we can make ribs and use dividers. This is gonna be an example of using it where we follow the sketch path and not parallel to the sketch path. Okay. So we can create divides in a caddy using the ribs and a draft tool. All right. So we're gonna make a new part, I believe. I don't think if we're in 6.3. This says 9.3. Should be in 6.3. 6.3. Is there a part 2? Yeah, 6.3 part 2. You can go ahead and download that from the classroom as well. This one, no, it would be 6.3 part 1. That was a bell ringer. All right, we'll do part 1. So we'll do a new sketch. We're in a new part. I double clicked. Do a new part. So home, new part, and we're going to make this caddy. All right. All right, so we're going to build this little caddy out. It's going to have 2 dividers in there to give us 3 compartments. And we're actually use a draft on this one. We'll talk about what a draft is in a second. This is, I guess you could do this kind of with an extrusion, but not necessarily. In order to do this, you'll need to first start a new sketch with the existing orientation. So we're going to go ahead and make I'm trying to see if we already have the rectangle or not. I thought we already had this part given because in the example, part 1. Yes, we do. So I'm going to go and throw part 1 in there for you guys. I'm going to download it. Classroom. I thought part 1 was up there, but it's not. Let me go ahead and add part 1 for y'all. Maybe we can save some time. 6.3 part 1. Google Drive. Put it in the topic. We are on day 8 already. I got 2 days left. Now we're day 9. 2 days left into this one. All right, so just posted that part file. It's 6.3 part 1 at the top of day 9, and this is what it's going to look like. Like this. This is what I want. Perfect. We don't make it. Normally we give this out. I don't know why it wasn't in the classroom already. I missed it. All right. So what we're going to do is we're going to use the rib tool to create a divider on this option. Okay. So in the emitter exam, there's a similar question to this one, and it already has the dividers drawn, or the section spots drawn for you. But we're going to go ahead and draw it. I'm going to give you a couple seconds to get it open, downloaded, and then we'll get started. All right. And after 6.3, we'll take a quick break, and then we'll finish up with the, I think it's machined holes is the end part. Okay. So now what we're going to do is we're going to go ahead and draw on this top surface. Okay. This little top edge of our shapes. We're going to click this edge and do a new sketch. Please make sure you're not drawing on the inside of the box, on the floor of it. You're drawing on the top surface of the box itself. All right, I'm going to do project geometry, and I want to project these edges, this edge, and I guess we'll also project that edge. And I'm going to draw a line across here, like so. and I guess we'll wait for 1, right? So we want to divide this section into 3 parts. So we need to figure out, well, how wide is this in general? So the measure tool will measure this edge. This guy is 23.5 wide. So I want to divide that into 3, and that's going to tell me how wide I need to space my stuff apart. So we're going to set a dimension from this guy to this edge and make it 23.5 divided by 3. And that's the space that I need. It's going to be spaced out that far. All right, we could draw another line over here and space it out the same distance. So draw another line and put it right there. And we'll dimension it from here to here. And I'm going to make it equal to this. You could have technically used a linear pattern if you wanted to, but I feel like that's kind of overkill, right? And then now we're going to go ahead and finish the sketch. And we have the same exact dimension values right there. And we have our 3 spacings. We're going to go ahead and do our 2 dividers with the rib. So now this one is not going to necessarily be parallel to our scenario. It's going to be normal to our sketch plane. So we're going to go and do rib. And you can see so this one is going to be side by side to our plane. It's going to be the parallel to sketch plane makes it go on either side of the plane. Whereas normal to sketch plane is going to make it, it's going to make the material go away from the plane until it meets another surface. So it's going to go from this sketch plane that we drew on to the bottom of our caddy. So we're going to choose, it's automatically selected. So we're going to choose our 2 lines. And the nice thing is that it automatically worked. I didn't have to change anything. The default buttons worked. If I chose to flip it, it's actually trying to go up, and there's nothing to support that's up. So, and you can even try different options. Nothing's going to work. So we got to go down. And then I also want to do a symmetrical one. That way it's the same on both sides. All right, it's actually taking up the right space. Let's see, what is the thickness going to be? It's 0.25. So 0.25. Right? And we also want to make a draft angle. It says a draft angle of a 5-degree draft. So we're going to go into our draft tab, and at the bottom we're going to do 5 degrees. You can see that it's changing it. If I look at the home view, it's changing it. The bottom is wider than the top. You can actually do it at the root. You can flip it, but it doesn't like that. It ain't going to work. So you can't do it at the root, but it's going at the bottom of it, and then you're going to press, make sure my shape is 0.25. Good. This doesn't work. That one just does top ridge parts. It's just open, which is kind of goofy. But we want this divider. Press OK, and it should look like this. You can see that it's different. Sometimes for planners, to save space, you can make that bottom area smaller than the top area, and that way you don't have to use as much dirt. Some people put wood or something, or I think there's some waste material you can put in there. I think people use Coke cans and stuff and all kinds of different things to or bottles to make it take up space and stuff. And a question on the minute exam is going to say, make the rib, right? What is the surface area of this surface? Just that single surface. So we want to use the measure tool and click just that surface. And the area is 73.906. The perimeter is 34.599. And that would be your answer for that one. And all right. So now we're going to look at part 2 that I had you guys download on. Please download on that one. So that one is in the Google Classroom already. It's under 6.3 part 2. You can go and download it. Making this would take a little bit too much time for us, so we'll make sure it's downloaded. We're going to look at it. So this one, while we wait for you to download it, I'm just going to talk about it, is that we want to use the rib tool to connect our large cylinder to our 3 main cylinders. And I want to demonstrate something too, because these 3 cylinders are actually, they're extrusions, but I want to use the pattern tool, okay? So let's go and get this downloaded. I'll give you about a couple minutes to get it downloaded. We'll start at 244. And I'm going to convert these cylinders to a pattern, and I want to show something. And that would actually be probably a good idea to change this in the, I bet the sketch is a pattern. They are patterns, but I want to do it in the 3D model mode. All right, so we should have it downloaded. So I'm actually going to modify extrusion 2. I double click it. And I'm actually going to deselect these two. So if you hold control and then click that, I'm actually going to make them go away. And then I'm going to use the pattern tool. Circulate the pattern. I'm going to choose this. I'm going to select this, and I only need 3 instances. And press OK. So in my class, I actually make them make it again. Like I make them make this part again, and then we add the rib. I like to torture the kids in doing Inventor, making sure they do Inventor because they want to complain. So I want to give them something to complain about. So I don't give them the part. But for the sake of time, I gave you guys the part. You can give the kids the part if you want. That's fine. But it's good to show, too, how to change things into different options because I want to show you something. All right, so now what we're going to do is we're going to go ahead and connect the rib once and then pattern it. Okay, so now here's the thing. So you have to think about your conventional versus your aligned section views. And that's going to help you think about this one. So we need to connect one of the cylinders, the small one to the large one, just one of them. And the easiest way to do this one is to have a plane that cuts through both cylinders, like perfectly. Okay, so what I'm going to do is I'm going to open the origin folder and we're going to click through our planes. XZ plane. And I'm looking for a plane that cuts through the large cylinder and the small cylinder. And you should have seen it being the YZ plane. So we need to draw on the YZ plane. So we're going to click New Sketch on the YZ plane. And look, this is my actual, not my conventional, but it's okay. We don't need it right now. We're going to click Slice Graphic. And it's going to go away. And we need to connect this corner to this corner. And you have to be careful, right? Because project geometry is going to mess you up if you're not careful. Okay, so here's what we're going to do. We're going to click construction line. Then we're going to click project geometry. And we're going to click this top line here and this top line here. Okay, the reason why we're going to do this is because project geometry tries to make the rib like all the way across the shape, and that causes some issues. I only want to make the rib across the line that we draw. Okay, so now we're going to press the escape button. We have to turn off construction line. So re-click the construction line button. And then now we're going to draw a line. So press L for line, and we're going to connect this corner to this corner. Just like that. And then we can click finish sketch. So we have this little connection here. And you can even see the construction lines right there. All right, now we're going to do rib. Now we're going to choose it automatically selected that line. And I need to be parallel to sketch plane for this to work. Parallel to sketch plane. Going to be symmetrical. Choose the second direction. And like it's not working. Fantastic. Should have been parallel to sketch plane. And this is why I don't like the rib sometimes, because it's just so finicky. I might have actually needed those construction lines to be solid lines. All right, which is fine. So we're going to put cancel because that didn't work. So in this case, I'm going to go ahead and see if making these lines visible lines will change it. That's probably what's going to change it. So click Sketch 3, Slice Graphic again, and I'm going to change these from construction lines to visible lines. I'm going to click on the construction line itself. I'm going to make it visible. Click on the construction line itself and make it visible. So when you click on the construction line, you have to click on the actual line itself and then click construction line button again. Then we're going to try that again. So rib, now it chose that entire path, which I don't understand sometimes, but it is what it is. And we're going to choose parallel, and it should have been symmetrical. Click direction 2. There we go. Right? So that got it. Strangely enough, that's what got it. Okay, so it needed to have that connection between my cylinders, and you can see it's like actually trying to rib like the whole shape. Excuse me. And but it's missing. So these holes right here is actually not. I'm surprised that it's not actually including inside the hole itself. But I guess because those are cuts and they exist above up here at the top, and where they live is above this rib. So they're going to actually be considered first, and they're going to cut the rib itself. Okay, so we need the thickness. I think 0.1 is going to be good. Excuse me. Let me see what we're going to do. Usually it's either 0.1 or 0.25 is what we're going to do. Equally spaced. And then it looks like 0.1 is good. 0.1 is good. Press OK. All right, so now that we have our rib on that cylinder connecting to it, we had to use the lines to go across. I just got a little confused on sometimes it messes you up, sometimes it doesn't. So it's just kind of finicky. So here's what I want to do. I want you to add the rib into the existing circular pattern. All right. Let me give you 2 minutes to try and add the rib to the existing circular pattern. Battery's draining, so I'm probably have to go to one screen and use my charger.
I still haven't gotten the rib to work.
Okay, hadn't got the rib to work. That's okay. Let's go over it again. So let's just go and restart from the beginning, right? Because this one's kind of finicky. Because I thought it was just the what you call it, the project geometry messing up. So we're gonna draw a new sketch on the YZ plane. We're gonna use slice graphic. We're gonna do project geometry. And we're going to choose this edge right here at the top and this edge right here at the top. Or actually, it's the front. Sorry. All right, and then we're going to choose the line tool, and then we're going to connect from here to here. All right, this path is going to create our rib. Press finish. Now we click rib. It automatically chooses this one, but I have to choose parallel to sketch plane. All right, it doesn't like this direction, so we're going to go direction 1, and it works. We're going to be symmetrical, and we're going to leave it at a 0.1 inch thickness. Did it work that time?
Not yet. Hold on. I was trying to delete something and it wouldn't delete for me. I had to go back and fix it.
Okay.
So rib. Okay, so like right now, it's not letting me select the line at all.
Okay. So
earlier, whenever I had it as a construction line, it let me select it, no problem. Now it's not letting me select it.
So mine automatically selects it without even trying. So let me see. Let me share your screen real quick. I want to see what it's doing.
All right. So in my sketch, everything seems to be matched up.
Yeah, it looks good.
Shows me that. I hit rib. It selects.
Okay. Yep, the line's selected already.
All right.
Now
so
click.
now
So you need to click parallel to sketch plane. Yep, and then choose the different direction. There you go.
I did that a minute ago, and I swear it didn't work. All right.
I don't know, man. I don't know. No, I'm joking. No, that's what happens. That's what happens when someone else is watching. It's gonna work. So there you go.
All right. Thank you.
That's it. Yeah, the rib's kind of weird. I mean, I don't see it being like that useful. And so, I guess like in other probably like more engineering application scenarios, like it's a good tool. I'm sure it is. There's like some kind of engineering aspect to it that might work pretty well.
While you have a second, can you go back to how whenever you did extrusion 2 earlier, and you said you hit control something and then you deleted the 2 without deleting the top one. How did you do that? Because mine, every time I do it, it doesn't. It like nothing goes away, and then whenever I click it, everything goes away. Like I click the X, everything goes away.
Mm-hmm. So yeah, that's your 2 options. You can just click the X and then just choose what you want. All right, that's one way to do it. I gotta zoom in and get it. There it goes. But if you let's say you selected let's say you had 8 things to choose from, and you selected a 9th thing, you would have to click this off and choose another 9 options. If you hold Control and then hover over what you don't want, it'll deselect it.
Okay, I've been trying to do that for a couple of days now.
Yeah, hold Control and deselect it, and that way you can just get rid of something pretty fast. And then
Yeah.
circular pattern. Good.
Frustrating for me is I'm so used to like on Onshape and on Fusion, there's like a list of every single profile. And so you can go in and you can select which one you don't want. So like where
Okay.
it says one profile or 3 profiles or whatever, there would literally be a list of every single profile that you selected. So like if one of them's not working, it would highlight that one red, and then you could go figure out which one that was, and then go make a like correction to it,
Huh.
which is very helpful.
Yeah, absolutely. That does sound pretty nice. Inventor can be a little difficult sometimes. I mean, maybe I don't know if there was another software that had a certification test to it that was the same quality or same like advanced level credential. I could see us moving to a different
Do they
software.
not anymore?
What's
You
that?
don't use Rivet?
I don't know if Rivet has I'd have to see what options are in Certiport. I don't know if Rivet is the thing.
I was using it for fluid dynamics, and you can see different, how water, after you build something, you can see how it protrudes and stuff.
Okay. Yeah, I don't know. I would say that the program has to be similar to what we're doing in this one. It needs to be a 3D modeling, very similar to Inventor, and then also has a advanced level credential test that would be the same caliber, and also
I just don't know about the test, but I would think so because we have to use it for our doctors.
Yeah, so I don't know. I mean,
And
it's definitely something to look into.
the subtitles are similar with the different levels.
Yeah, I feel like Revit would be similar because it's an Autodesk software. So I don't know. It's possible. All right, everybody get the rib on there. So with the next task was I wanted you to add the rib to the already existing circular pattern. Add the rib to the already existing circular pattern.
Which means you just got to change the order, right?
Change the order of what?
Where the rib is and the circular pattern is. Flip those two.
You're onto something here. Right. So Josh knows what we're doing on this one. So what's frustrating is if you try to edit the circular pattern to include the rib, you can't. There's no rib there. It's gone. It disappeared. Right. What's happening is that the rib is in order of the circular pattern. The rib is below it. Okay. When a circular pattern, you can only choose what's above it. Technically, according to the timeline of the circular pattern, the rib doesn't exist yet. Okay. It's like that the Back to the Future example, right? How Marty McFly shouldn't be able to go to the past at all. But anyways, so you can't choose the rib. So press OK, but you can move and change the order of it by hovering over the rib, clicking on it, and dragging it above the circular pattern. And then now when I double click circular pattern 2, I can now choose the rib as an option. So we can just add the rib to the pattern, and then you literally just click the rib, and then everything else stays the same. Then press OK, and now you have that shape. So that's a weird thing. I mean, I feel like if something's made, it should just be able to grab it at any point in the process. But that's how the model menu works for Inventor. It's an order process, and anything below it doesn't exist according to that one option. Anything above it does. Okay. So that is it for that one. That should be it for ribs. And that is it for ribs. All right. So let's take a little breather. Take a little 5-second break to use the restroom, stretch, get some water. We're going to finish up with machine holes, which ain't going to take us very long. And we'll look at machine hole drawings. And then we'll be out of here by 2:30. All right. I'm gonna go. I need to go get a charger for my laptop, anyways, because it's about to die. So All right, and break. Let's see if there's a bell ringer or something. I don't know. I don't care. We'll go. All right.
So, having taken robotics and now this course, I'm starting to notice a bit of a trend in the way that a lot of these classes do their stuff, homework wise at least. It's a lot of the same or similar material over and over again, just shown in a like the same picture. Let's say like we've seen this picture, I don't know, 3 or 4 times now, and you just learn different ways of doing it that are
Yeah.
more
It,
refined or more
yeah.
effective, whatever the word might be.
Essentially, it's like, all right, here's the way to do it that is pretty simple and tolerable. Now, at this point, we're going to do the same thing, but now it's advanced. It's like we're going to do it with a different, like more efficient, but it's more complex design to it. Yeah, absolutely. I agree with that. Yep. That is a good point on that one. Can you hear me? My work? Yeah, it is. Okay.
Yeah, you're good.
All right. Because I can see the little level thing bounce up, but it wasn't like really responding that well, so I wasn't sure. All right, let's go and close that. Close that. Close that. I don't know why that's still open. Okay. That is not my Google Drive. I thought it was over here. Okay, it's over here. That is not all backwards. Where is my drive at? I'm just gonna open it up again. All right, we're gonna look at. I guess I closed my Google Drive. All right, so let's go look at 6.3 machine holes. All right, and we'll talk about the different types of machine holes. This is where I would go into the 5.1c machine holes special convention. I'm going to kind of breeze through these a little quick so that way we're not spending a ton of time on it. But essentially, like a machine hole we're going to use the hole button. Okay. If you look at Inventor, there's a hole command right here, and basically what it does is it gives you these options to do different holes, different seats, and then you can adjust the values and the distances of those special seats. Now, you could technically do all these with the extrusions and revolves and all these different things. But the bonus value of doing a hole is that in the drawing files, the hole command actually gives more information than just an extrusion. Okay, so when we do the drawings and we do the hole type, it'll actually tell us and give us all the little symbols that we need for those holes whenever we look at them. Okay, so that is the bonus, and they're also pretty easy to use in the most part. So this is kind of like the symbols that we have. We'll look at it. So this is a counter bore, spot face, countersink, and this one shows the depth. So we get angles, depth, height, and those values will come in play. All right. So we have 5 types of holes. The first one is just a regular hole. That's what we do for the most part. That's just like a basic extrusion cut, like you see on the right-hand side, this green cylinder. That's an extrusion cut. That's just a blind hole, but it would not register as a blind hole in the drawing software because we didn't actually use the hole command. I said a blind hole, like a regular hole. A blind hole is a hole that it doesn't go all the way through. This one goes through the entire shape. The blind hole stops a certain distance in the shape, so it gives us a different type of symbol. Counter bore is like a rectangular cut. So if you ever assembled like IKEA furniture or any of that, easy to assemble, supposedly easy to assemble furniture, they have like these recessed holes for the special screw types they have. That's going to be a counter bore. A counter sink is think of a sink. It's like a funnel shape. And then a spot face is just a counter bore, but skinnier. I don't really know the difference. There's no difference. So here's a through hole, and the symbol that you get right here. So 0.5 inches, and it says through. So when you see this through symbol, that just means it goes all the way through the shape. Blind holes will look like this one. They're going to have whatever type of hole first, and then it's going to have this little symbol in red right there that tells you the actual distance that it's going to go into the shape. So you can see from the side view that it actually, and you can even see the drill bit right there, that how far it goes into it. Here's another one. It's telling you how far they go in. Here's another blind hole example. It has this right here, and the question says, what is this? I just told you what it is. That's the end of a drill bit. It even shows you the depth. So also to note is that the depth of the hole, the measurement value, is actually measuring the hole minus the tip of the drill bit. Okay, so that's something to kind of point out as well. So here's a counter bore symbol. So this counter bore, there's 2 of them. The diameter of the counter bore itself, of the hole itself, is 8 inches, or 8 millimeters, or whatever we're using. It goes through all. The counter bore, so the width of this, or the diameter of the counter bore seat, is 13.5. And the reason why I know which one's which is because the counter bore should be larger than the hole itself. All right, and the counter bore's depth, and this has to be millimeters, is 8.5 millimeters. So that would be the dimension values that we would put on that one. All right, counter bore right here. This is just like the symbol, so diameter, and then you have the counter bore, and then you have this could be the number of them, counter bore symbols, and all that different stuff. So the program does that part for you automatically. It's actually really nice and convenient. All right, here's another counter bore thing, and this is what it looks like. So when we talk about the depth of the counter bore and the diameter of the counter bore, that's what we're talking about. Here's counter sink. So it has like more of a funnel shape to it. We go more of the angle of the counter sink, and then there's no distant depth of it. It's just more of the angle. But it has a diameter, the diameter of the counter sink, diameter of the hole, and the distance that it goes. So like here's an example. So the counter sink right here, the diameter of the hole itself is 10 millimeters. It goes in 30 millimeters. The diameter of the counter sink is 20 millimeters, and it's at a 90-degree angle. So that's just kind of what we're seeing there. So a spot face is just a counter sink, but it's skinnier. Like it's slimmer, it doesn't go in as much. That's really the only difference. That's the difference. And then here's like kind of an example of like how they look on the drawings. And then we're going to do some in a second. All right. So we're actually going to make some holes right now on Inventor. Okay. And then there's thread pitch that we found out today that thread isn't actually real. It's just basically an image. So let's go ahead and look at making some holes. All right. So let's go ahead and make a new part. I can actually do full screen on this one. I don't really need those notes right there. So I basically like compact all this into kind of one thing, and like that's why I don't showcase the I don't do the what you call it, the holes in the drawing stuff. That way it kind of like breaks apart and it's not as complicated and we don't have too much going on. So we're gonna do new part. I mean, but you can still do it. It isn't a big deal, but I'd prefer not to. So I'm gonna do a new sketch on the, let's say, front view. We're gonna do a 2-point center rectangle, and I'm gonna make it even. So I'm gonna do we'll do 6 inches wide by 2 inches tall. That should be enough material. There we go. 6 by 2 rectangle on the front plane. And we're going to extrude that 2 inches. Let's go with 3 inches. 3 inches in whatever direction. It's not a big deal which one. All right, we're going to talk about how to make the holes. Okay, so you have 2 options here. Okay, and option 1 is probably going to be the best option. So option 1 is to click the hole button, or you can type the letter H on your keyboard. And then you're going to put a point. You're going to pick a point of where you want that hole to go. So we'll start at the beginning, right here. All right. Now, before I do anything, I want to go ahead and align my sketch. Now you should see in the hole command, there's a sketch 2 option. It automatically creates a hole and a sketch. It creates those 2 features, those 2 things simultaneously. I'm going to click sketch 2. And you can kind of see where this guy is going to be located at. So now I want to go ahead and dimension them every 2 inches, right? So it'll be 2 inches for the first one, 2 inches for the second one, 2 inches, 2 inches. That way they're spaced out evenly. Okay, so dimension, the center. Where's the center? It's not letting me grab the center. Should be. That's kind of weird. So let's go ahead and make the hole, and then we'll go back and edit it. Because you should have been able to move that around. I don't know why my... Okay, I can move it around. Okay, there it is. But why can I not dimension it? So can we use constraints? Whoops, I did not mean to do that. What did it mean? Start. There we go. All right, hole. And place the hole here. Go to sketch. Because I like to position my step before I make it, but for some reason it's not. Okay, it is. I just don't notice it. Okay. So I did a horizontal constraint, and then I'm doing dimension from the center here to the edge here. It is doing it. So it's kind of weird because I'm not seeing that that thing. Actually, I need to change my rectangle. So we're going to press Control Z until this goes away. All right. And I'm going to edit this extrusion, and I want it to be, I'm going to edit this to be 8 inches wide. 8 inches wide, not 6, because it's not going to work. Because I'm doing 4 different holes, and if I did 4 different spaces, it'd be wonky. All right, now click hole. Now we're going to put it right here. Now we're going to click sketch 2. I'm going to do a horizontal constraint with the center of my hole and this right here. I don't understand why it's not like showing anything, but it's working. Dimension the center of my hole to the edge of my thing right there, and that's going to be 2 inches. All right, every 2 inches we're going to put a hole, which I don't think this is still. Yeah, it should be 4 of them. They should all fit. We'll see. All right, now we're going to go back to hole, and we're going to modify it. So first off, I just want to do a regular simple hole. I don't ever change these. I guess you could, but we don't do it. I just leave it on simple. I'm going to go to no seat, so seat none. And we'll leave the diameter at 0.5. That's okay. Let's do termination. We'll do fixed distance. We'll set that one over here. So now, if you look at it, your termination, you can do through all. You can go up to a surface, or you can just leave it on a distance. You can change the direction of the hole, which we don't want to change it because nothing will happen. We can have a drill point. It could be flat, or it could be an actual angled drill tip. You could even choose variable ones if you want to. And now right here, you're going to change everything else. So our extrusion was a 3-inch extrusion. So this is actually going to go out the end of it. You can even see the end, how it's going to make that drill bit tip. But I'm going to change it to a blind hole. I want to go in 2 inches. I just want to go 2 inches. All right, and then we'll leave everything else the same. The diameter is going to be the same because we set the diameter already, 0.5. I was able to modify that already. It's right there. And we leave this angle how it is. I don't mess with it. Advanced properties is we don't use it. So basically we have a regular hole, simple hole, no seat, termination, leave direction 1. I am going to use a drill bit angle, and the distance, the depth of it is 2 inches. The width of it is 0.5, and we're going to leave this degree how it is, and we're going to press OK. All right, just like that. And I'm going to do something. I'm going to go ahead and, yeah. All right. So now the other option is to create a sketch on the front view and then put a point. You're going to put a point like right here, and then we're going to dimension it to be, should be 4 inches, which should be on the origin, 4 inches from the edge. And there's going to be, and you can put another point over here, another point over here, it depends. But I still don't think this is going to work out. So I feel like we're going to have an empty space. So I'm going to have to move this guy over and move this one over too.
Might
So
want to do 1.5 for your
yeah, that's what I'm
spaces.
going to do. Yeah, absolutely. So we'll do, this will be, this will be 3.5. And then, or actually 2.5. That'll be 3 inches. And then I'm going to go change this sketch and make it 1.5. I pretty much should just stay where I was. So every 1.5 inches will be good. That'll work. Okay. All right. So now once we have our point put in place, I'm going to go back and edit sketch 3. I'm going to do a horizontal constraint, make sure it stays locked to the origin, just like so. And now we can click hole, and it's going to automatically put the hole where that point is. So you have a couple options. If you want to put them, if you want to just click hole and edit things after the fact, that's perfectly fine. If you want to make a sketch and then it places it where that point is, that's also fine too. This time we're going to do simple hole again. We're going to do a counter bore. We'll make the termination go through all. Now this is the part where you have to set it. So right now the diameter of the hole itself is 0.5, and the counter bore is actually 0.375. So it doesn't like that. So I'm going to set the counter bore to be 0.5, and I'm going to set the hole to be 0.25. And then the depth of the counter bore will just stay at 0.25. That's okay. Now you notice there's no drill bit end because I did through all. But if I did termination, then I would have a drill bit end. But I'm doing through all because it's going to go all the way through the shape because it's cutting through the whole thing, and there's going to be a hole at the end of it. Okay. And press OK. So I prefer to just do hole, put it here, and then I'll go ahead and put where I want the hole to go. We'll say from this one to this one, we'll do 1.5, pretty close. And this one we'll do, let's try 2. That's good. 2, and then go back to the hole. This time we're going to choose a counter sink hole. This one will terminate that one. We'll do a termination at a certain fixed distance. This time I won't use a drill bit. I'll use a flat end. And I'll set the counter sink to be 0.75 wide. We'll leave it at we'll do a 90-degree angle. 1 inch. Why is the drill bit option not happening? Determination. Right. Do drill bit end. Let's do a 1.5 inch termination. And then we'll do it at a 0.5 inch hole. I'm just making up as I go. It doesn't really matter that much. All right, then we'll put one more hole. This time I'm just going to use the hole command. I'm going to click over here. We're going to do a spot face. I'm going to go sketch 5. We'll do dimension from here to here. 1.5. All horizontal constraint here to here, and go back to the hole. And then now we'll do a spot face. We'll do a drill bit. We'll do a through all. Diameter with this will be, we'll do 0.5, and then this will be 0.125. And that looks good. The spot face will stay at that value because it's pretty much like a countersink or counter bore, but just a little skinnier. Okay. Those are our 4 different hole types. You can see them from different positions. All right. Let's go and save this part. This is going to be 6.4. Part 1. All right. And that is a hole. And that's pretty nice little tool. I don't mind using it. It's a pretty simple tool to use. It's adjustable. And then also it's going to give us our values from our drawing. So now we can go into our drawing. So go to the home icon down the bottom left and make a new drawing. We'll do our anti-A drawing. And then we'll go ahead and put our base view of our holes. And we'll do the top isometric and press OK. All right, we'll even practice with some section view drawing. So what I want to look at is, let's go and I'm gonna make this one a little smaller. We'll do it's a half scale already. So we probably should change the sheet size paper, but it's probably fine. We'll do a 4th scale. Make it shaded. Yeah, that's good. Put that at the top. I'm gonna do a section view for this one so we can see the internals. I'm gonna delete the top view. I'm gonna do section. Choose the front view, and we'll go cut it in half. Do a full section. Right click, continue. Like that. So you can see the internals of it. And move this down a little bit. All right, now this is where the Inventor component comes into play. So now we're going to go to annotate. And we're not going to click dimension. We're going to click hole and thread. Okay. So now we can click our holes, and now it's going to give us way more detail on our different hole types. And that is the main value of using the hole command over just doing like an extrusion cut. Okay. So that is the difference. Now you have to use this hole and thread option. And if you use the hole, it would actually use that command. There's a chamfer, there's a punch, bend. I don't know where the punch and bend stuff comes from, but this works for that hole and thread command. And just one more application is like changing. Don't forget, you can change the material types. Let's go back to our part 1. Let's change it to, we'll change it to gold. Right now we want to go back here to our drawing and we'll change our material to gold. So highlight the hash style, double click it. Let's find gold. Let's see if it's an option. We have gold as an option. I don't see gold isn't an option for us. So let's go press OK. And actually wood should be an option. So let's change it to wood. I don't think we use that as an option on the Inventor exam, but it's just, what the heck, why not? Let's do cherry wood. There we go. And then go back here and then double click it and then go to ANSI other. You would have to select, where is it at? Woods right here. And choose it and press OK. And then press OK. Now we have a wood pattern. So kind of neat. And that is pretty much it for holes. Let me double check there. Anybody have any questions or anything? Everybody doing all right? You can get into all the details of thread pitch and stuff and go over that value. There's aspects of dimensioning. You can review that if you want to, or if you have the time. Student handout. We're gonna skip over that one. And how's everybody doing with this one? this? 6 machine holes. Feature notes. Just looking to make sure. Yeah, that's basically it. You're just positioning it. Really not bad. Yeah, that's it. So that covers machine holes. So we got Unit 6 done before 2:30, 3:30. So how's everybody feeling about machine holes? Any questions on them? They're not bad. They're pretty straightforward, and it's pretty nice how you can the dimensioning tools make it really easy. So it's really not bad at all. So Unit 6 is pretty straightforward. It's really not too complicated, especially for like a later unit. So thinking about it, we probably could move Unit 6 up if you had to. So I remember, Josh, you were talking about doing that pumpkin project. The only thing is how fast you can get through the drawings, and then doing Unit 1. I wonder if you could do this one in Unit 2. What do you think?
I mean, like I said, I'm used to going through a lot of this stuff at a little bit faster pace,
Mhm.
and so the whole stuff, usually stuff that I've always found they get easily because it's kind of more of a almost a memorization type thing where they have to remember the types
Yeah.
and the different stuff, which for a lot of the kids who I was teaching last year, at least they like that because they weren't exactly great as engineers. They were
Hmm.
kind of just random kids who wanted to take the class. Um, so having something that they could go in and actually just know was good for them. Now, I don't know how much it shows up on the quiz that we would be given, but it, I don't think that this stuff is very hard as far as the making of the holes in the tool itself.
Yeah,
Um,
but like with sweeps and lofts and especially sweeps, because that pumpkin project required them to do sweeps. Um,
yes, no, it's heavy.
yeah,
It was fun, but I mean, I was dealing with a bunch of freshmen, and we did it before October, so we did it early October,
yeah,
and they all except for I think one kid who wasn't in class for like 2 weeks, they all had a pumpkin that they successfully made.
yeah. Okay. So I mean, it's definitely an option if you want to try that out and see how it goes and stuff. But yeah, I thought Unit 6 could be done a little earlier. I mean, if anything, but it's a pretty good lesson. It's really not bad. I think this is probably like my easiest time is this part right here. Like it's relatively straightforward. It's nothing too extra, I guess, too complicated. So it's just a
Well, and
thought.
it's after all the other stuff, so
What's that?
at this point, it's after all the other stuff, so at this point, it shouldn't
Yeah,
be terribly hard.
absolutely, absolutely. So yeah, so I mean that's an option too if you wanted. I was thinking of that doing that project. You could think about doing it then, or maybe not. Just follow the order and you get to it whenever you get to it. So yeah, just a idea, thought. So all right, so that is gonna be it. So let me look at the classroom for the assignments and stuff. Where's my? I have way too many tabs open. Here we go. Day 9. So today is just the sweep and rib homework, and let me click assign that one, and then the quiz. All right, which should let me look at it. Make sure I'm not letting you guys walk into another doozy. I'm like, oh, this is gonna be easy. Like, don't worry about it. No big deal. Like, and then this is insane. All right, because yeah, that last one was quite crazy. All right, so quiz.
Wasn't
All
bad. It
right.
was just unexpected.
Yeah. Blindsided. Blindsided. All right. Create a sweep using the path profile provided. Create a work plane offset from the XY plane. Yeah, you guys can do stuff like this. You'd be good. Create a rib. Yeah. So this is basically stuff that we did in the today. So not worried about it. It's not too scary. Not too scary. Maybe a little scary. All right. So let's go ahead and edit this guy and copy. Okay. All right. The homework just got issued, or it's assigning.
Sorry, Logan.
Yes, what's up?
Excuse me. I'm just watching the videos, and yesterday I watched the day three. So I'm far
Okay.
behind, and just I have no access to the PowerPoint file.
Okay. So let me see. The PowerPoint should be in 1 second. I have to make sure. I'll make sure you get access to it, or we'll figure out
Okay, thank you.
access. Okay, so no problem. Part one.
So it should be lesson 023.
Okay, I'm gonna take a look at it and I'll make sure you get a hold of it. Okay.
Okay, thank you. And also, I have a question regarding the RIP Revolution conventions. So
Okay.
I understand from the top side how to draw that, but for actually the right side, honestly, I didn't get how did you draw it. So if you can
Okay.
just
Yeah,
re-explain it for me.
let me get these assignments ready for everybody, and
Sure,
then we'll take a look at it.
sure.
Okay.
Thank you.
Yeah, no problem. All right, so I've added everything on that one, and it's got the topic already. All right. Making sure this goes through. I didn't forget to do it before you guys leave. All right, so the homework and the quiz are posted. So if you guys don't have any questions or need any help and you're ready to go, I feel like this quiz should be pretty good, not too bad compared to the other ones. I know that. So I know I have a question I'll take care of in a second. So if you're good to go, let's get a sign out word. Let's see. It's kind of cloudy outside, so let's just say cloudy. Cloudy is the sign out word. All right, so to sign out today, that's what word you're going to use. If you guys don't have any questions or any help, you're free to go. I know I have some assistants we'll be going over in a second, but other than that, you guys have a good day, and I will see you tomorrow on Friday. Oh, I did a direct message and not a general
I
message.
don't have any questions, but I'm still on. I'm just working on some of the other assignments. So I'm just on, but I really don't have any questions yet.
Okay, that's good. Yeah, no problem. That's all right. That's okay. All right. So, Muhammad, which which PowerPoint were you needing access to make sure you get it?
Okay, it's lesson 0.2.3.
All right, 0.2.3. Okay.
And my question is from slide 13.
All right, 0.2. Yes, it's not on there, so let me go and add it on here.
Thank you.
No problem. 0.2.3. All right, it's the drafting conventions one.
Yeah.
Okay.
So I understand from the top side, but from the right side, actually, I don't understand why that actual convention.
All right, let's take a look at it. It is a little different. So I just put it on the Google Classroom, so it's under day 2 at the
Okay.
top. So, yeah, so that's gonna be drafting conventions. Yeah. All right, let's take a look at it. I'm gonna go and share my screen.
Day 2 or day 3?
Should be day 2.
Okay.
Yeah, day 2. All right, share screen. All right, so what was your question on that? What slide was it?
So slide 13.
13. This right here? Yes. All right.
Yeah.
So this one's
My
confusing.
issue, yeah,
Go ahead.
actually, I cannot understand that actual and
That's
conventional.
okay. That's okay. So if and it'd probably be easier to show the shape itself. So like I can actually visualize a little better if I see the material. So let me make this shape real quick and then show you. So I'm just gonna make it real fast. And then we'll make another circle over here. Do that. Okay, this is gonna be generally the same, similar shape, but not exactly, probably.
Okay.
But it'll still have the same application to it. All right, and then I'm gonna go in. We don't need the rib part, just pattern it. All right, so when we have an object that, especially if there's an odd number of occurrences like this one,
Mm-hmm.
I didn't grab the second extrusion right there. There we go. Especially with like an odd number of occurrences like this one, and this one's kind of like offset from this one. So I probably could have positioned it like a little different to where it's more or less like that. That's better. That's better. Just like that one. So this is in generally pretty close to the shape. I just didn't include the rib part to it. So when we're looking at this one, let's say this is the front view and it's not rotated like that one. So when we look at it exactly from the side profile, like this, you can see, especially if you look at it from this angle right here, these two guys kind of overlap with each other. And
Mm-hmm.
also, this top one doesn't look like the same length as this bottom one. Okay, so that's the actual look of it. From the actual side view, this has the top, but from the side profile, this is what it physically looks like. Okay, so now what we want to consider, what we want to look at, is we want to account for the conventional size of it. So what happens is we get a lot of like overlapping lines, like especially the hidden lines. The hidden lines are all kind of like condensed right here on this little rectangular blue outline, and it's really hard to tell where everything is. So when something's like compacted like that, there's this center line. You see the center line in yellow right here? This is the
Mm-hmm.
actual like diameter of each one of our appendages on this scenario. So while looking at it exactly from the side profile, like even though that is the physical way it looks from the side view, we can actually go off of it. We can actually like elongate those sides to make it represent two of our shapes, so that we can, number one, we stretch it out. It's not as condensed. There's not overlapping lines, and we can omit a couple of things to make it easier to see, basically. So like, while this isn't physically what it looks like from the right side, but it
Mm-hmm.
matches up with this right here with the diameter of our center line. And if we were to rotate it, each one of these little arms would actually go this far high, right? It would actually be this tall. It's just from the exact side profile, the physical actual view, it's not technically looking that way. Does that make sense?
Yeah.
Yeah. So that's the difference between actual and conventional. So it's not like a huge deal, but it is that's why we use the conventional over the actual.
Okay, got it.
Okay.
Thank you. And also, I have a question from slide 15.
Slide 15. Oh, the runouts right here. Yeah.
Yeah, I also didn't understand this folding at the end because there is no folding. Actually, it must be vice versa when we look from the top. So exactly this folding marks with red inside red. It must be vice versa. But why there is that fold?
All right, so the runouts on the top part right here, and this
Yeah.
one and this one don't make sense to me. But it's the main thing is that when we have these is on a curved surface. So when this part right here meets this flat surface meets the curved surface, see this triangle slope doesn't actually meet the curved surface on the bottom of it, but it does on the top of it. So anytime like a linear surface is connected to a curved surface, they use these things called runouts. So like right here, this one on the left, in this little blue rectangle and the red circle, this is this showing this curvature of the cylinder. But to be fair, it's honestly not super important to use them. You can actually get away with not using them, but it's just to demonstrate that this material is connecting to a round surface. So like down here, this one right here, and there's actually like a rounded part right here. These two are the same thing. They're just different positions, and honestly, they're not. Actually, the shape's not the same, but they're not. That's not necessary. But this down, actually, like this down here, that's necessary. This one is connected to. Or actually, the top one is. The top one is. I'm looking at the wrong view. The bottom
Yeah.
one's not. This one's not necessary. This one is. This one's not. This is a weird drawing, but yeah. So it's just indicating that a flat surface is connecting to a curved surface. That's all it is.
Okay.
Also, I didn't notice that this corner right here, this doesn't make sense either because it's like a squared off view. I don't know. This is a weird drawing. I would stress that this is not something to worry too much about.
Okay.
Okay.
Thank you. Yeah.
No problem.
Thank you. Thank you so much.
Right. Yeah, no problem. Anything else?
No, thank you.
All right. All right.
Just the word of the day was coil.
Yep. The sign in word was coil, and the sign out word is cloudy.
Sign in was coil.
Sign in was coil, yes, and sign out's cloudy.
I only did the sign out. I have to do the sign in.
Yeah, you should do a sign in and a sign out. Yes.
Can I do it backwards now?
Yeah, that should be okay. That's all right. All
Hey,
right.
on the homework 6.1, it has, you want us to save it as 9.1. Is that just one of those things we hadn't updated yet?
That's just something that hasn't been updated. Let me go and look at that. Thank you for catching
Do
it.
that 6.1. I just want to make sure.
Yeah, do 6.1. I missed it. I'm gonna go fix that right now. 6.1, you said homework. It still says 9.1.
Yeah, whenever you have the save request,
Oh, I
it
see
says
it right there.
please save the file as type, whatever.
I was being lazy, probably, and I just didn't see that directions. There we go. I just fixed it. Thanks for the catch. Yeah, if y'all catch anything like that, that's
You're changing all those little things. There's a bunch of them.
dude, there's a ton. I spent hours just going through and looking through each little thing, and I missed probably a few of them, probably at least 5 or 6, probably.
No, it'll be all right. We'll figure it out.
Yeah, I think everybody can draw conclusions from it. Yep. So, all right. Anybody else have any questions or anything for today's topic or anything in the past? All right.
No, I'm good. I need to just submit some things.
Okay. All right.
On
you guys-
our stuff, are the grades that we're like the stuff that we're submitting, does it matter if they get graded or not, or is it just like a
Yeah, I was trying to go through and grade some of them, but then I just got lazy. But like, it's more or less
no.
turning them in.
Right,
Is the big main concern. Yeah, Vanessa was saying you need to turn in at least 80% of the assignments, at the very least, and
Gotcha.
that's usually the threshold.
Okay.
Yeah.
Did y'all do the pre-test and know what we did?
I'm sorry.
The pre-test?
Yeah, everybody took it at the beginning. That's correct.
Yeah, I did it. Did it show up?
Yeah, let me check. I can double check real quick.
And do we supposed to know that, Greg?
No,
I
it's
think
not.
I was guessing a little too much.
No, that's okay. That should not be good. That should be you shouldn't. I mean, unless you've done all this stuff before. Yeah, I got it.
Well, it's kind of like Rivet.
Okay. Yeah.
Don't tell me if it's that bad.
No. It shouldn't be. It should not be. It should be a low score, but I haven't looked at it yet. But yes, I got your submission. Yep, you're good. The main thing is to improve and to get a 70% on the whenever you're done. So at the end of it on Monday, Monday's agenda thing is going to be going over the project folder, but that's not going to take more than an hour. I don't see why that's in a whole day, but like our whole session. So I'm going to breeze through that, and we're going to try and get out of here a day early, and not have to come back Tuesday for the post test. So
We got to
so
get 80% done before Tuesday.
Say it again.
We have to get 80% done before Tuesday.
No. So like, especially since you came in late, no, it's just before summer's over, then your assignments need to be completed 80%, and then before you leave on Monday/Tuesday, you need to get a 70% on your post test. Yeah.
So the question is when, as I do it and you're not on the Zoom, am I going to just text her or something to check it out to tell you, or what?
Yeah, you can just email us. Yeah, we'll take a look at it. Yeah.
I don't think I have your email. Or yeah, you did send it, didn't you?
Yeah, I did, and it should be connected. And if you email Vanessa, that works too. It's fine either way. Yeah, she has all the authority for everything. So.
Well, I would like yours in case during the semester. Now, right now, I don't know if I'm teaching it this year.
Okay.
Because they had only 3 kids and they didn't know that I was going to be able to take it. So at the beginning of the year, I get to push it on, see who wants to join our former students when they get back, and we'll know. But if not, it'll be the following year, which is a refresher, even though and maybe I can just take it again without having to pay, right?
Yeah, you just do a refresher. Yeah, you could probably pop in on the sessions that you need or whatever. It should be fine.
Okay, but that's if I don't teach it.
Yes, I mean, even if you don't teach it, all you would be required to do is the refresher course. So.
Okay. But I mean, my whole thing is I'll find out at the beginning of the year because I'm going to try to get my principles of engineering students in it. Okay. They kept telling me they want it, but I don't think they were able to list it or something because it wasn't available at that time.
Yeah, that should be an easy fix for y'all in the beginning.
Yeah, so I will know sooner, but I'm still going to try to get all of it as much as possible done.
Yeah. No, that's okay. That's all right. That works.
See you tomorrow.
All right. Have a good day.